Good morning, sir. Garg, sir, good morning. Sumit, it seems Professor Garg has again got disconnected.
Yes, sir. Sir, join again and make co-host.
Okay. Good morning, sir. Good morning, all the participants.
Good morning.
Good morning, sir. Thank you very much, sir. Sir, I hope we can start now.
Yeah. Shall we start? Okay, all right.
Sir, wait a minute, sir. Dear participant, I welcome you to the first day of the first session, direct first session, although ICT has started its inaugural session for the 15 FDPs that are going to start from today. I welcome you formally for the application, the AICT Atal Academy sponsored faculty development program on applications of remote sensing and GIS. And our first speaker will be Professor Rahul Dev Garg from IIT Roorkee. Sir is professor in Department of Civil Engineering, IIT Roorkee. He is BE, ME and PhD from IIT Roorkee. He has about 27 years of experience in the field of geomatics at ISRO and IIT. Sir is currently like the special division that sir is handling is geomatics department. So he has about his research interests are land surveying, satellite image processing, optical thermal microwave and hyperspectral remote sensing, subsurface investigation using GPR, ground penetrating radar, GIS and GPS, UAV, LIDAR. He has supervised more than 22 PhDs and currently 12 are under process, and 57 MTech theses he has supervised. He has published more than 125 research papers in international and national refereed journals with high impact factor. He has authored one book, 11 book chapters, and presented 146 papers in the conferences in India and abroad. He is involved in a number of international and national research projects, consultancy works, and various schemes. He is associated editor of Journal of Indian Remote Sensing, Indian Society of Remote Sensing. 45 years old, prestigious publications by Springer. He has won prestigious ISRS SPAC award in 2003. He has been conferred more than 5 best paper awards. He was awarded 15 months fellowship by the Netherlands government to pursue research work at ITC, the Netherlands. He has organized 28 international and national training courses and delivered expert lecture in different parts of the country and abroad. He is a fellow of IEI and IWRS, senior member of IACSIT Singapore, and member of several professional bodies. Sir has received National Geospatial Award in 2018 by Indian Society of Remote Sensing. He has received Uttarakhand Eminent Engineers Award in the year 2018 by Institute of Engineers India, Uttarakhand State Chapter. He has been conferred Outstanding Teacher Award in the year 2012 by IIT Roorkee for excellence in teaching and research. Also, sir has received Excellence Award in 2017 by Institution of Engineers India, RLC. I welcome you, sir, again, and thank you very much for accepting our request to deliver the expert lecture. Thank you very much, sir. Kindly start.
Thank you, Dr. Pawar. Thanks for your invitation, as well as I also welcome all the course participants because I feel that these are the refresher course where you can refresh your knowledge as well as you can have more zeal to go for the research work using the technology as such. All right. So with this, I will share my presentation. Are you all able to see it?
Sir, yes, it's visible, sir.
On the last, I don't know how it has happened. All right. I hope everybody is able to see it. Okay. So in this session, we will like to just deal about GIS fundamentals and analysis. So as told by Dr. Pawar that it is the first session of this course. So just we will start with fundamentals as such. What are the GIS fundamentals? maybe possible a few of you or maybe several of you are aware of GIS. So we will like to go with fundamentals, as well as I will also take slightly advanced topics, although this session is more for the fundamentals as such. So basically, what is a geospatial analysis? This geospatial analysis has got three technologies. Okay, here we say that geospatial is not only for GIS, but it is for the three technologies which form the 3S technology. These are the remote sensing. It is acquiring information from the remotely sensed data. Then there is GIS. It is a geographical information system. It deals with data management, manipulation, analysis, and visualization in the computer environment. And next is your GPS. GPS deals with accurate positional information. So GPS, I hope all of you are aware that it is for a global positioning system. So these three S technologies, why S? Because remote sensing has got S, GIS has got S, and GPS has got S. The three S technologies are the backbone of geospatial technology. It means if we say only GIS is for geospatial, no, remote sensing and GPS, they also contribute equally in that. So with this, in this session, we will focus more on the GIS only. But you know that other two technologies also help GIS for various type of aspects. So why GIS is needed before starting any course? Because nowadays everybody want to know that why he is asked to learn this, learn that, etc. So we start with why GIS is needed. So basically GIS is for making the maps dynamic, displays the map information interactively, build the spatial relationship between the features. Like you may have a number of features in your study area. So what is the relationship between those features that can be established by GIS? Analyze to answer the real world problem. So we will take one example, that what type of real world problem may occur in front of you and how to solve it. Yes. So when we define the GIS, it has got different type of definitions. One is the toolbox based, because people say GIS is a tool. So that toolbox definition says that it is having a set of tools. Some say it is a system, because in the name itself, geographical information system or system is there. In the name itself, information is there. People say it is an information system because it is for giving the information. So using this type of toolbox definition, what we can say? We say that GIS is used for capturing, storing, retrieving, manipulating, analyzing, and displaying which like the information which are spatially referenced to the Earth. Why Earth? In the word geographic, we have got geo. Geo means Earth. So you see that here also the word geo has got spatial reference to the Earth. It means we are dealing with the Earth. So you see that these all are the terms which are the tools, like capturing is a tool, storing is a tool, retrieving, analyzing, displaying, all are the tool. So it is for the toolbox based definition. But we see that all these things are just the summary of GIS. When we summarize the GIS, all those things will be useful. So we can have the database based definition, a database system in which most of the data are spatially indexed and upon which a set of procedures are operated in order to answer queries about spatial entities in the database. You see that every definition, it revolves around the same type of concept. Like you may have a tool, you have to apply over a database, or you have a database, you have to work over that database using a tool, etc. And ultimately you have to answer the queries about the spatial entity. GIS has got this spatial thing, it has got this strength that it can record the spatial data, it can record the spatial information, and it is able to handle the spatial queries. What is the spatial query? That any question which is related to the space. Okay, just for example, I need a particular vegetable at a particular time. So that is just my simple query. But I want that particular vegetable which is coming from a specific region because I want that taste. So all these are the geospatial query. So like that, it handles all this type of question. We will see some example of the queries. Organization based definition, suppose an organization is using the GIS. So what type of internal questions can be asked from GIS and what it is able to answer? Those all are the organization based GIS. So this definition says a decision support system involving the integration of spatially referenced data in the problem solving environment. Okay, you know that nowadays our car hiring companies, Ola, Uber, etc., they are also using GIS in the backdrop because they have to send the vehicle which is not hired at a particular time to the nearest position. All right, so I hope if you have used the app from Ola and Uber, so it also shows the location of the nearby empty vehicle or unhired vehicle. So like using that information, you can simply call a vehicle, whatever you want to hire. So again, on that basis, if you want to define GIS, it is a powerful tool for solving the real world problems. And most important thing here is that GIS can make the real world problems, it can make the real world information into different layers. So now we will try to understand the layer concept. Look, below there is the real world and it has been recorded as land use. It has been recorded as streets by district boundaries, parcel boundaries means land ownership, etc. You can also go for the underground information like for sand and gravel, sandstone, aquifer, about the water table depth information, rocks information, shale, igneous rocks, etc. The river and the discharge point of the river in order to make a watershed. So just a simple question may arise in your mind. Why we have different type of maps for a single entity? Our Earth is a single entity and you might have seen the topographic maps produced by Survey of India, which has got all the information in the single sheet. So why not we go for that one? So answer is in GIS, it is capable of manipulation. It is capable of analysis also. So suppose I want to find out location of the bridges in my particular area, then having the street map as well as having the river map or canal map, the intersection will give me the location of the bridges. If you have all the information in a single sheet, it will become clumsy as well as the information you require may not be available instantly. So here putting it separately, you want to work on street map, you take the street map and work. You want to find out what is the land use of the area, you take the land use map and work. And one more important aspect at this particular time, like segregating the information into different maps is very difficult, but combining them together is very, very simple. All right, as I told you, combining the street map with the river map will give you the location of the bridges. So that task is very simple in GIS. That's why it has been told you keep each and every theme. All these are themes like land use is a theme, street is a theme, etc. You keep all these themes separately, and whenever you require, you can combine them. You can overlap them one by one. So on the basis of all these things, again, we can say GIS is a method to visualize, manipulate, analyze, and display the spatial data. So again, now again, we will see so many type of definitions. So you see that with this, we can have the type of GIS, what are the different type of GIS, desktop GIS, which we have in our computer. Then we have professional GIS, that GIS is specific for a particular application. Professional means it is for the professional people who want to have a more advanced tool, etc. Enterprise GIS, enterprise may be for a particular organization. So for that particular enterprise, Like that enterprise may be the power corporation, it may be the transport company, etc. So that unnecessary, or you can say the unused type of routines, unused type of functionalities can be segregated, and you can have only the useful functionalities of that. Mobile GIS can be on your mobile also. Nowadays everybody like to use this computer type of functionalities over this mobile only. That's why you can have a mobile GIS which can just roam around with you. So the GIS database as well as GIS functionality is there. Then we have the internet GIS. It means that you will be able to access the functionalities over the internet, and the Google Maps, Google related this websites are one of the best example. You find out the location where you want to go. You just feed the location from where you want to go, and it will show you the path, etc. All the things can be shown. And again, the same functionalities if you use over the mobile, like the Google Navigator over the mobile is a very useful tool. Platform is different, but the system is almost the same. Then we have the embedded GIS. People nowadays have got some device, it may be the Thunderbolt internet, this laptop, it may be a small palm top, etc. In foreign countries, the organization, they produce this type of embedded GIS so that their worker can go to the field and collect the data on the spot. So all this type of GIS can be used for number of purpose. Now, one very fundamental type of slide from the GIS, it says that GIS describes our world. How it can describe the world? So we describe any object in our world in two ways. One is a location information, where exactly it is, or the coordinate information. Secondly, attribute information. So what is attribute? Attributes means adjective, or attribute means about the particular object or feature. So you see that basically what we have two questions. One is where it is. So it is your coordinate. Second is what it is. So it is for the details about that. So this tree is having oak species, and height is 15 meter, age is 75 years, etc. So this particular object can be recorded with characteristics, means attributes, as well as the location. So it means that it will be one entry in our GIS map. And similarly, all the available objects, if we simply enter, if we simply feed into GIS, it will make a complete GIS. All right. So for that, we require the locational reference system. And as we say that here also, we have taken the latitude and longitude. So latitude, longitude are the very simple type of coordinate system. Advantage is this system is showing the unique coordinate for the entire world. I hope you are aware that latitudes are you can say, these are the east-west lines which are moving from equator to North Pole and again equator to South Pole. Equator is considered as 0 degree latitude. North Pole is 90 degree north latitude, and South Pole is 90 degrees south this latitude. And all the other locations are just marked in this manner. So what will happen? You have got one coordinate which is as per the y-axis of the Earth. Okay. Now we have got another coordinate which is for the x-axis. So these lines as such are moving from north to south, but their values are varying from east to west. You can see that here we have got in latitude, we have got the equator, because the equator divides the Earth in two equal parts. But here we do not have any reference. So that's why, can you see this small portion that is United Kingdom? So from UK, there was a very old observatory that is at Greenwich. So you can say that it is a Greenwich observatory. So location at the Greenwich Observatory was considered as the 0-degree longitude. You can see that it is not any physical feature, but just a line. So this line was considered as 0-degree longitude, and the entire globe has been divided into two hemispheres, Eastern Hemisphere and the Southern Hemisphere. So you can see here that from the 0-degree longitude line, if you go towards the east, so values are increasing 10, 20, 30, 40. It end up to 180 degree. If you go towards the Western world, then it is 10 degree west, 20 degree west. And again, it goes for 180 degree west, where the line will be the same, which is having 180 degree east and 180 degree west at the same location. So this is one very important type of system. Combining latitude and longitude, you will have a grid type of system, which is just a coordinate. The coordinate along the x direction, a coordinate along the y direction, which will show the unique position of the Earth. So you all might have used other type of coordinate systems like UTM, etc. But for all those coordinate systems, you should know the false origin. So the coordinates may repeat themselves. But in latitude and longitude, coordinates will never repeat. That's why it is the simplest system to understand. All right. Now, nomenclature of the GIS. Right now, we are just going around the GIS because you may be having certain confusion that people say that LIS, Land Information System, is also a GIS. Spatial Information System is also a GIS. So we are telling that they are correct in one aspect. So these are the different names for the GIS. Some people call it as geomatics. Like earlier, the term geoinformatics has come. Geo and information here. So geo, you know, is Earth. Information about the Earth. Some people have reduced the geoinformatics and started calling it as geomatics. So there are so many nomenclature for GIS. In different countries, they call it as a slightly different. So now we have one very important slide about the GIS. What exactly GIS depict? All right. So as such, when we say GIS, name says it all. But we have to understand the implication. It means that now all the terms, individual terms, geographic information, and the system, they will be understood. So what it literally means, what it indirectly implies, and what it. So all these things we will like to know. So geographic word literally means that abstract representation of reality. So when we say geographic, you know that geography means we are dealing with Earth. So most of you have studied geography in your coursework, etc. So it is the representation of reality by the graphic objects such as roads as lines, cities as dots, etc. So we used to do the work like that. In our geography classes, we used to draw a map where we have to draw the roads, sometimes rivers, hillocks, etc. we need to draw. So that is the literal meaning of geographic. Information means storing data about an object and about the spatial relationship. System, we all know it is a connected set of processing tools. All right. So we are having some tools which are connected, because if the tools are not connected, they are disjointed, then we will not be able to use them properly. Then what geographic indirectly implies, objects are related to each other, to the Earth, by the real world coordinates. When we say geographic, it means that it must be for the Earth, as well as objects are related to each other. It doesn't mean that one hill we talk about that belongs to Earth, and another hill belongs to Moon or Mars, etc. So they all belong to Earth only. Information, when we have some information, what for it is used? It is used for querying the questions. So querying the relationship to answer the question that we want to do. And one very simple question which can be answered how long is this road? If you have a full map, if you know the scale, you can answer this question, how long is the road? All right, so just you will be able to answer the question if you have information, and if the information is in structured form, it will be easier for you to answer the question. So now what this system implies? Dependent on the range and quality of input and output methods, tools, and interoperability. So you see that when we have a system, we expect that it is able to do some work. Okay, what these offers? Geographic offers units of length, areas, etc. There are real world units, and we can zoom to any scale we like, and we can just make them zoom in, zoom out, etc. It means increase the size, decrease the size, and we can extract the real world information out of it. Modeling a complex system we can do with the information. I will just come to it. Let me cover what system offers. It offers a graphic display, because when we have a system, we need to see everything as a map, etc. It should be interactive also, and it should work within the limits. Whatever functionalities are there, we should be able to use. Now, we come back to this particular statement and let us try to answer it. And one more thing I will like you to think, in order to answer it, what information is required? Look, how long to the airport on a rainy Tuesday at 5 p.m. I am driving a Maruti. Okay, so first this word is how long. This long may be in two terms. One is for the distance, that how much, like how far will be the airport, or how much time it may take for me. Because when you are going to airport, sometimes the time required is also important. Airport may be next to your house, but you may have to take a longer route to go there. All right, so that is first question, how long. Second one is to the airport. So I can answer this if I know where is the airport. Okay, if I don't know where is the airport, how can I answer this? And there is a sub question attached to that, where am I? So you should know your location also. It means it requires, this particular phrase of the question requires two information, where you are as well as where is the airport. Okay, so you should know about it. On a rainy Tuesday, look, these two terms are very important. It is a rainy day, there may be a causeway or there may be a road which gets flooded in rains. So it may be a shortcut. It may reduce my way by few kilometers, but if it is a rainy day, I should avoid taking that route. Otherwise, I may miss my flight. That route may be full of water. So on a rainy day, I have to choose it according to the roads which are free, which does not have the chances of water. Tuesday may be a market closing day. Tuesday may be a street marking day. Accordingly, I will take the road. I hope you all are aware, because most of you reside in big cities, and even if you are living in a small city, you know that sometimes the market area is very difficult to commute, even on two-wheeler in the daytime or market time. But the same area you can move on the four-wheeler with the speed after market. So it means that Tuesday, whether it's a market day or market closing day, at 5 p.m. again is an important thing. 5 p.m. is the office closing time. So I should take extra precaution because the streets will be crowded at 5 p.m. And now again important thing, I am driving a Maruti. Suppose I may be driving a two-wheeler, then it would be easier for me to commute through the streets which are crowded. To commute through these streets which are not very wide. But I am driving a Maruti, means four-wheeler, so I have to go accordingly. And one more thing, suppose I am driving a truck. So there may be few streets where Maruti is allowed but truck is not. So it means that so many questions, so many types of data I require in order to answer this simple question. And now please remember your daily life things. Every day, every time we used to answer so many type of questions, we may or may not be using GIS directly or indirectly. We may not be able to study GIS, but we answer all these things. So unknowingly, we all are using GIS every day, every time when we have to solve this type. Okay, I hope that it might have energized your knowledge bud. So we all are doing GIS. GIS is not anything Spanish or Greek. So we all can do the work in GIS very well. So again, these the definitions, I will not read it. I just only want to say that there are different scientists who have got good name in GIS. So all these definitions are given by them. So one is by Marvell, by Clark, by Burrow. I hope a few of you must have studied the book by David Burrow. It is one of the very important and prestigious book by Barry, by Michael Goodchild. And again, there are definitions by USGS, United States Geological Survey. And then we have got definition by ISRI. I hope you all are aware. ISRI is the creator of the ArcGIS software, which is one of the prestigious software. Then NASA, and then again McDonald and Kemp, etc. So many type of definitions are there. Ultimately, all the definitions say same thing, but with different type of wordings. So gathering the information from these definitions, we have come to the generic definition. What is generic? It means the grassroots level type of information is there. So generic definition is again highlighting the different type of tasks which you have to do in the GIS. So what it is? So GIS is a special purpose digital database. So earlier people used to ask, can I do GIS without computer, etc. Because that was the time when computers were not very popular. Some of the organizations were not having computer. So it means that it's a digital database. It means it will work better with the computer, in which a common spatial coordinate system, that is what we have studied. All your data should be having a common spatial coordinate system, because otherwise one data will stand here, other data will stand here. You will not be able to join that data. And it is a primary mean of reference. Coordinate system is a primary mean of reference. Comprehensive GIS requires means of. So now the four things are the four type of tasks which you perform in GIS. First one is data input from maps, aerial photographs, satellites, surveys, and other type of sources. So these are for creating the GIS. Next we have data storage, retrieval, and query. Retrieval is for the data which has been stored. So you need not do any type of analysis, but you get the data directly as you have stored. Querying means you are doing some type of query which may require any analysis or which may not require any analysis. If it requires any analysis, it will require the transformation. It means that changing one type of data to the other type, then analysis and modeling, including the spatial statistics. Then data reporting such as maps, reports, and plans. So this is the part of data output, which is also very important, because unless you have some output type of procedure, you will not be able to disseminate your finding to the common user. Because you can't ask any common user that, okay, you go to the GIS software, apply this type of steps, do this overlap, do this spatial filtering type of things, and then you will get your answer. No, you have to give the answer in the format that is easily understood by the user who is not a GIS expert. So it means that two things are input and output. Third thing are data storage and query. And the last one, or you can say, although it is an intermediate step, data analysis and model. So these all are the part of GIS. GIS as such has got a capability that it can have a link with the other type of software. Okay, so GIS can be added, GIS can work hand in hand with other type of software, just like DBMS. DBMS, you know that it is an integral part as such, because GIS functionalities work on the database management system. So this star means the strength of DBMS is the full database functionalities which we use in GIS. Then the CAD, computer aided design. You know that in CAD, AutoCAD is one of the prestigious software. In GIS, ArcGIS is a prestigious software. But looking at the capability of GIS, AutoCAD has come out with a GIS software, that is AutoCAD map. All right. So it is having all the functionalities of AutoCAD, because few people are still very much conversant with the AutoCAD. Those who want to make maps, number of time the surveyor also produce the results in the AutoCAD, etc. So how to combine the results of AutoCAD with the GIS? Nowadays, almost all the softwares, they give this type of functionality, that your AutoCAD files can be directly imported to the GIS for further working. So AutoCAD has got one advantage, that it is having a good graphic output. So all those who have worked on AutoCAD, they may also say that it has got very good type of graphic output with good accuracy. Same type of accuracy we want in GIS, but AutoCAD may be having a local coordinate system, GIS may be having a global coordinate system. That's the only. Then we have image processing. You know that one of the important input of data to GIS comes from the remote sensing data. Remote sensing images are the raster images. So you see that what will happen, you process the satellite data using the image processing tools, and then you input the information to GIS. It will be one of your major tool or asset. So the importance of image processing is in raster creation and manipulation. Then we have the 3D modeling. In 3D modeling, you can prepare some model using the advanced softwares on 3D. GIS also can incorporate this 3D modeling, because whatever distal elevation model you have prepared using GIS, it requires certain section making and other type of 3D modeling fundamentals of functionalities that can be done. Then the desktop mapping, we have discussed that the output of GIS should be usable by the common user. So desktop mapping help in that. And then again, the graphic package, which have got good flexibility, etc. It means that GIS can incorporate all these things. And now what is the capability of GIS? What is the strength of GIS? The strength of GIS is the topology. Topology deals with arranging the features with some relationship, as well as you have the connectivity between the features. Okay, so we will just see a few slides about the topology at later. So now just I will like to go a bit fast, because it may all be just like a theory for you. So what are the low-tech regions? It means that, okay, why we use it at all? Using a map as a way of viewing commercial data. Real estate company might keep a map locating properties with respect to the houses, schools and shops. You know that sometime a user also want to choose the shop or the house for its own use using a GIS. So all this type of application, they make use of GIS as a desktop mapping tools. Some high-tech regions which are directly linked to the technology, finding relationship and patterns and anomalies that are not apparent to the eye. For example, real estate company might notice that a particular area is ahead or behind an apparently similar area and tailor their marketing differently to compensate. You know that nowadays this marketing as well as tourism company, they are finding new and new untouched areas which are having low cost, which are not yet crowded. and they want to sell it for those customers who don't want to see crowd in the place wherever they go. So it means that all these things like connectivity, what are the facilities available, they all can be done by the GIS. So management of resources, some predictive modeling for a well-known area, GIS can be used to discover and test the quantitative relationship, etc. Some application areas for the natural resource management, for the facilities management, and again in the land management, in the network planning. You see that these are the major areas wherein we have got different type of functionalities which use the GIS as such. Now, one of the important thing which we should discuss about the GIS, that is the different components. You see that hardware, software, data, methods, and people, they are the 5 components which we use in GIS. And hardware means what type of hardware, whether it is strong or not strong. You see that if you have a good computer system, your GIS will work properly. But at the same time, you need a good GIS software, which is having proper functionalities and other type of things. In GIS software, I will like to add one thing, that nowadays 2 basic type of softwares are there. One is the commercial software for which you have to pay money. Other is the open source software. Nowadays, the open source field has been developed in such a manner that the open source software, they give approximately similar functionalities as the commercial software. So earlier, about 10 years back, if somebody want to start working in GIS, he has to either arrange some commercial software or go to a place where the commercial software is there. But nowadays, you can directly use the open source GIS software. No need of purchase, and still all the functionalities are there for your analysis. So just it is important for the common user who does not have the funds to buy a GIS software. Next is data. Data is very important. You have the good hardware, you have got the good software, but without data, your analysis will not be having much value. So you should go for a good database. You should go for a good database management system, which can hold your data in proper manner. Then people. If you arrange everything, but there are no people who appreciate your efforts, who say that, okay, whatever your findings are, they are well taken, they are really useful, then it will be of no use. That's why we try to create the users for GIS, so that those users can use the data, whatever you are producing, and take the field further. Next is the method. Method is very important, because a successful GIS operates when you have got the well-designed implementation program and business rules. Okay, so without good method, without good functionalities, and without it is like the subroutines. So I want to do a particular task, it can be done by GIS. I want to go for that task, I want to mix the 2 things. So all these should be included in my methodology, in my methods. So I should be able to perform everything properly. So functional model. Okay, we have discussed so many things, and functional model is nothing different. You see that that functional model, it says that data input is there, database is there, they both are linked together. And then we have got query and analysis. So query and analysis will be for the database, and using that we will be able to produce the output. Then the linkages can be seen. Data input, it is for creating a database. Then query and analysis, database, the data will be sent and it will be taken back. So it is a 2-way process. And now after query and analysis, we find the output as well as we visualize the things, whatever we have produced. Okay, from database also, as I told you that there can be a data retrieval also. There is no need for analysis, but I can directly use the data for the output and visualization. Different type of queries which can be asked in a GIS software. Okay, so what type of queries are there? First type of query is the what is type of query. So what is this one? So you have got certain feature, you want to know more about that. For that, you go for the what is query. So display of data as the maps, reports, and tables. For example, what are the name and address of the owner of that parcel? All right. You just click on a particular parcel of land. You want to know the name of the owner. You want to know the address of the owner. So do you think it is possible from the common type of map? Because it is showing the location of that parcel, but it does not show who is the owner. That is possible with the GIS. Why? Because along with that parcel, you have attached a table which is having name of the owner and addresses. And you know one thing, all these things were earlier taken as just one hypothetical idea, or just thought that, oh, what is the use of that? Nowadays, government revenue department, they want that information, because if they go to a particular place, maybe the land is in acquisition or for some other purpose, they want to know whether the person is paying the revenue or not. They want that information, and all the database, all the revenue and land database is now computerized, so that all this information is available with the government as well as common. So it means that this particular question is not a hypothetical question that we want to use it only for science. We want it on ground also. So now it has become the ground reality. So storage and query functions are there. What type of pattern? That may be a question. A pattern in the data, all parcels within area greater than 2000 meters. So suppose I have to establish a factory. So I want to go for the land parcels with more than 2000 meters square. What is a pattern? Means that whether they are inside the industrial area, or they are at the periphery. What are the other type of this facilities available along with that? So query function with the constraints. What if a prediction about the data at a certain time or at a certain location? So that is a modeling function. So all these type of queries can be answered by the GIS. What GIS can do? Identification where it is, locate what is there, trends, what if type of questions, patterns, what has changed, like you want to know if I provide you the population data for the ground, so which area is having higher rate of population increase, which area is not. And one of the very common application of GIS which is used nowadays is the urban sprawl. If you see any city, the city is not growing uniformly, but it is growing non-uniformly. At a particular pocket, it gets people's emphasis. So what will happen? That particular pocket will grow very fast. All other pockets will grow very slowly. All right. So that type of trend, that type of pattern, we can analyze using the GIS. Optimum path. What is the best route? Models, what type of relations exist in between. All right. Suppose I say that a particular locality has got houses with more than 500 meters square area. We say that other locality has got houses with more than 100 square meter area. So what is the relationship between these two? So like on that basis only, we call a locality as a posh locality, and call one locality having more this possibility to rise, etc. Now, data structures, very important concept in GIS. So you see that all the geographical data can be reduced to three basic topological entities. Topological means which can be plotted. So here it is point, line, and area. So you sit coolly and then try to find out. There may be a geographical entity, there may be a geographical feature. If you want to represent it as a map, if you want to plot it in a map, how will you plot it? So here it says that all the geographical data can be reduced to three basic concepts: point, line, and area. Area is also known as a polygon. in several GIS books, etc. You will see that basic geographical or graphical elements are, one is point. A point is having a coordinate x and y. Next, you have got a line. So what is a line? Line is an array of points. So if you compile more number of points, then it will become a line. So there is a starting point in a line x1, y1. There is an ending point in the line xn, yn, and intermediate locations can be simply given by x2, y2, x3, y3, x4, y4, etc. So if you have only the starting point, you have only the ending point and no intermediate point, then what will happen? You will have this as a straight line. Okay, this will be taken as a straight line only. So that's why what we have multiple coordinates so that you can define the shape of the line. Next is area. Area, what area is having? Area is having the same starting point and the same ending point. It is just like the line, but a line is starting at one point and ending on another point. But the area means the line is starting and ending on the same point. That's why it's starting at x1, y1 and it is ending also at x1, y1. So x1, y1 is called a node. Okay, here this starting point x1, y1, x and yn is called the nodes. All other intermediate points are known as vertex is singular, vertices are plural. All right. So you see that all the geographical entities can be represented by point, line, and area. So apart from it, these are the geographical thing. Apart from it, what a map should have? A map should have a label. What is a label? Label means you have your books, you put your name, etc. Just on the first page. So that is a label. You want to identify what it is. Like you have a point. Simply having a point may have an xy coordinate. Simply having a line may have an array of point coordinate. But what exactly it is? That is a label. Label says that this point is the location of a temple. This point is the location of a police station, post office, etc. All right, this line is a canal, this line is a national highway, maybe state highway, etc. So that is a label. Label is also needed to identify what the entity is. Map is a series of points, lines, and areas. So when you compile all this information into one sheet, that sheet is known as map. All right. So map is a set of points, lines, and areas that are defined by their location in space with reference to a coordinate system. So when we say that map, it should have all these type of functionalities, whatever we have studied earlier. So it is having point, line, and area. It is having a coordinate system, and it is also having that non-spatial attributes. It means that when we say a GIS map, it is also having all those information tagged with it. You know, when we have a parcel, how can we know the name and address of the owner? Because that table, that information table is attached to that. So for that, we used to do it. We have a map legend. Map legend means it is for explaining the symbols, etc., whatever we have used. It is a key linking non-spatial data to the spatial entities. Colors, symbols, and shading are employed to visually display the non-spatial information. All right. Then level of abstraction, it says that suppose there is a geographical feature. Suppose there are a cluster of houses. So the cluster of houses can be mapped as per the land parcel. There are 4 houses and 4 land parcel A, B, C, D. And the sides have got some names like 1, 2, 3, 4, 5, 6, 7, 8, and then inside partitions. And you know that we have studied that like everything on the ground can be stored as point, line, and area. So the same thing, this information is stored in the form of a table. So this is the point table. That is the line table. Line is known as the arc. So it is the arc table. Area table is known as the polygon table. So all this type of information is stored in the table. That is a part of data structure, and it is stored to the computer as the file structure. So that is the level of abstraction in information organizing. From the real world, you can go to the file structure in this. So again, changing data into information, it requires that you are giving data input, conversion, editing and verification of this data, and organization is structure, database, updating this data. You see that sometimes the data is old, you need to update also. So this database is used for modeling and analysis, and ultimately you are able to produce an output. Okay. Now we are having one of the important functionalities of GIS, that is the file and data structures, whatever we have to use with this data. So you know that earlier, suppose the data is stored in the registers, and how it is kept? It is just kept as a simple list. So simple list is unstructured, and new items are added at the end. So just like I take the attendance of the students, and I just ask the name of the student and simply write in a register. So whosoever is coming at whatever time, I am writing in that sequence. But at a particular time, I want to search a particular student, whether he has come to the class, whether he has come on time or not. I have to go for the entire list as such. So instead, what I can do, I can make an attendance register where every student's name is entered as per the roll number or as per the alphabetical order of the names. I just mark whether that person has come or not, present, absent. If I want, I can also write the time of entry, etc. Then that will be a sequential one, that the data will be in the sequence. So the simple list is just a very crude manner of storing the data. Access time is very slow. Next type, a sequential one, it is just like the dictionary or the phone book, or just like a teacher's attendance register. So you will be able to get a better type of search in comparison to simple list. If you want to go for some indexed types. So what is for indexing? In indexing, suppose a student has told his this name, you can search by the name. Suppose the student has told his admission number or enrollment number, you can search by that also. It means that indexing can be done as per any of the field. So what will happen? That you will be able to find the required data easily. Like I suppose want to segregate who is absent or who is present. So just by one click, the entire table can be indexed in different format, and I will be able to get the required answer. All right, so that is the indexed one. Indexed one normally go with the computer, consists of direct and inverted file. So just for example, there is a flat file structure where there is no this relationship between the data, no sequencing. But after you make some sequencing, it will be better to use. After you make indexing, indexing may be as per the taxation number, street address, the name of the owner, etc. Then you will be able to do the work in a better way. Same type of file structure, if you go with the database structure, it will be better, because a database structure can store the spatial information as well as attribute information. So basically there are three types of database structures. These are hierarchical, network and relationship. Hierarchical database structure work like a parent-child relationship. So what is that? Suppose we take this small example of a map. Map is having two polygons, A and B. Each polygon consists of four sides. There may be more than four also, but in this example, we have got four sides as such. Look here. And each side consists of 2 points, 2 endpoints of that side. So now, if I want to store this type of map, then what will happen? Look, first, it is the grandfather, you can say. It is M, so that is the map. It has got two branches, one for polygon A, another for polygon B. So after we have got two polygons, then again individual polygon has to be seen. Polygon A consists of four sides A, B, C, D. Polygon B consists of four sides D, E, F, G. Then each of these sides have got two nodes, one starting node and other ending node. So A is corresponding to 1 and 2, B is corresponding to 2 and 3, and so that you will be able to do the points. So same type of thing, we have studied that point, line, polygon, they are capable of producing a map. Same thing has been done, but this is having a system, but this system is good for a particular type of hierarchy. It is not very good for each type of database which you want to store. So easy to understand, obviously update and expand is easy. They work well if the structure has all possible queries known to you. Just like the bibliography, in bibliography, you may ask either by name of the author, by the field of the author, name of the publication, etc. But if you don't have some structured query, so there can be an unknown query. So disadvantage will come because you have to include the need for large index files with certain attribute values repeated so many times. Can you see here? This A is repeated here. So A is not common, but here D and D are repeated. This 1 and 1, 1, all these here again 1, they all are repeated number of times. So there is much redundancy. Redundancy means duplicacy. So data duplicacy is there. Although hierarchical is slightly better than your indexed or the flat file structures. We go for another one. So in hierarchical, what we do? Different type of tables are just linked with respect to a common field. So as you can see, a common field is the taxation number. So that number has to be repeated for each of the table in order to have linkages. Next is a network system. In network system, what we do, each feature is written only once, but the pointers are repeated. Can you see that this D is common in between the polygon A and polygon B. So D has been written only once, but D is connected to A as well as B. Similarly here, point number 1 is connected to here A, D and G. Can you see that 1 is connected to A, connected to G, connected to D and G. It means that the connectors are more. That is a network type of system. It allows linking the features, but at the same time, there are so many connections. There are so many type of things. And if there is a small change in the database, those connectors need to be updated. So that is again a cumbersome system that should not be done. So normally network system is good when you have a network of some features, just like the road network, a drainage network, etc. Then it is good. Otherwise, the network system also is not good. The most important system which is in use these days, that is the relational type of system. In relational type of system, we establish the relationship about each other. As you can see here, the features can be divided as different tables. The first table is for maps. Maps A. Map has got two polygons A and B. Then we have got polygon table. Polygon table has got each polygon A, which consists of the sides. A polygon consists of A, B, C, D sides. B polygon consists of D, E, F, G sides. Each side now from A to G, each side or each line of the polygon, it is made up of 2 points. So the points also are written 1 and 2, 2 and 3, 3 and 4, etc. Now each point, how the points be defined? Points will be defined by the coordinates. So x1, y1, 2 is for x2, y2, etc. So it means that each and everything can be defined with the relation with respect to the map, polygon, line, and points. Please note that in the relational type of system, there is also the data duplicacy. because the same data has been repeated here. The polygon A and B are also in the map table, they are also in the polygon table, but at the same time data has been arranged in such a format. If you want to know only about points, you will go to the point table. If you want to know only about the lines, you go to this table, etc. That's why relational database system, RDBMS, is one of the mostly used system for all the type of things. All right, so that's why we can say that RDBMS is the most common GIS, this database structure which we use. So it is again having this one. So you see that a single type of field need not be repeated. Here it is the taxation number, which is linked to this table with taxation number. But other tables, they don't have taxation number, but the other fields are there which can be linked. So here subdivision and block lot are linked. They are linking this table to this table. This owner address and owner 1 and owner 2 are linking this table to the other. All right. So user determines combination based on the table or the relationship. All right. Then we have got the data models. So earlier one is the database. Now this is the data model. So GIS stores information about the world as collection of the thematic layers that can be linked together. So it has got two type of data. Spatial data, we have seen it. That is the coordinate data. Attribute data is the adjective or the characteristic data. These two type of data is there. Using this type of data, we can understand what is the data structure which can be used in GIS. So just see that GIS has got two type of data structures. Please remember, earlier one is the database structures. It means that how we store the database. Now it is the data structure, how we store the data. Look, just below, you have got a real world. I hope you are able to see the mouse. So this is a real world map as such. This need to be converted into GIS. There are two methodologies. One is the vector, other is the raster. So how to store it? Look how the real world, this area can be stored in the vector. They can be stored by the real lines over there. And each and every feature is stored over here. So this is marsh, this is the lake, this is grassland, and again the forest land, etc. can be seen like this. But the raster has got everything as the grid. So you divide the area as the grid and then the store the feature. It means that vector and raster, they have got different type of representation for storage of data. So a raster view of the world, it says that suppose you have got different type of features. So it is a part of the map. So we prepare a grid, and please note that size of the grid, how much should be the spacing, etc. It depends on you. If you have very small grids, then your data can be represented very accurately, but at the same time, size of the data will be very high. So the size of the grid you have to decide on the basis of the storage space available, on the basis of the requirement. So then you do the sampling, and in sampling what we do, the map is having the grid as the overlaid one. So now depending upon the different type of grid cells, so which feature they are occupying, so you will be able to just prepare the raster map according to that. All right, so you can see that the raster is being prepared from bottom to top, depending upon the occupation of the grid, that what the grid occupies. Can you see that? So in this manner, a grid can be filled by only one class. You cannot fill the grid by two classes. And according to that, whatever is the majority class, you will fill it up here. All right, I hope you are able to understand how this map with the grid over that is prepared into raster map. we have got a lake. Here the lake is not fully covering this grid, but in the raster map, you have to show that the full grid is covered by the lake. There are some extra things. So, but since they are very less, you can't say that this particular grid is covering that one. So that's why this is the raster map which is prepared of the map. One thing can be noted over here, that it is the crude representation. Like this is the shape of the features and this is the shape of the features in raster as such. The look wise, the aesthetic wise, raster does not look good. But I should share at this time, raster was the technology which was in use long back. Why? Because that time the computers were not having that much computational capability. So raster was the easy solution. So raster, this GIS type of sheets are easy to do the analysis, while the vector are a bit difficult. But nowadays, with the very good type of hardware and software available, now people are taking care of the vector. So we can say that raster and vector, they have got different properties. So raster-based system displays, locates, and stores graphical data by using a matrix. Vector representation of an object is attempt to represent the object as exactly it is. So vector is giving you a better representation, better aesthetic. So we can see with this figure that we have got the three basic geographical entities: point, line, and area. So point, line, and area are represented just by the coordinates in vector representation, but just by the grid or combination of grid. So this point may be a dimensionless quantity, but here in raster it has to fill one grid. So now it has got some dimension, because you can't have multiple features for it. This road or a river may be going like this. It may be having some vertices and nodes, but now in the raster it has to be just prepared like this. So you see that the width of the road or the river becomes 0 at the junction, but we don't have any other solution. Okay, either you increase the width of the road or river at that particular location, otherwise the aesthetic wise it will come like this. In area, you have to fill in the internal cells in order to show that you are representing an area. All right, so accordingly you have to work. So again, a raster model that like over there, you have got a map like this, and how all these are filled, B, B, A, like that. So entity information is explicitly recorded for a basic grid cell. Same thing for vector. So this information can be recorded as this one, as a table of XY coordinates. So here we have got again one example that how the vector soil map can be stored as a raster. So you see that here it is stored as a color or this thing by the polygon. If you simply have a grid which has to be filled by numbers, you can see that the same thing, number 1 1 2 2 2 2 1 1 2 2 2 2. So the lower one is just representing it just by sake of values. This is a very interesting slide. You see that whatever are the advantages of vector, they are the disadvantages of raster, and vice versa. We will just see it like this. Advantages of raster is accurate graphics, positional and accurate area calculation. Look, disadvantage of raster is inaccurate graphics and area. Advantage of vector says that pleasing visual due to retention of detail. Disadvantage of raster says that blocky experience with loss of details as pixel size increases. Advantage of vector says that compact data structure, small storage requirement, but the raster says disadvantage is large storage requirement for the raster. Same thing, we go for the advantages of the raster. that will be the disadvantage of the vector. So advantage of raster is easy to perform spatial analysis, but in vector it says that complex data structure is required for vector. Simple data structure it is here, and spatial analysis hard to perform, very complex or impossible. So it can the raster can import, display, or manipulate the remotely sensed data. Vector can't handle the remotely sensed data. So I told you that one of the major inputs for GIS is remote sensing data. So raster is able to handle that in a better. So again, these are various functionalities, the precision in graphics, precision in analysis. Few of the things vector is having. Updation and integration, it is very easy in raster, but it is difficult. We can't say it no right now, because the softwares are very you can say robust these days, but we can say that updation and integration of the vector database is very difficult, not easy. Some compact methods of storing the raster data now with increasing the storage space. These all are not very much required, still we can see. So there are 4 methods of storing the raster data in compact manner. One is the chain code, second is the run length code, third is the block code. So if you just come across all these terms, so then you can easily understand these are the compact methods of storing. Sometimes the file structures are also having this name, like you may find .rlc file format in a number of softwares. Okay, so just all these they're showing, we can skip. There is a quadtree type of system. In quadtree, we divide the entire map into different type of blocks. And then whatever has achieved saturation, like now this southeast portion has achieved saturation, we will stop. Otherwise, we will just go on dividing them further. So that is a quadtree structure. This is one of the computer-based structure. So nowadays, it is one of the very commonly used structure for making the storage size less. We just have an example, so we will go fast through this example. You see that for this map, I have to compress it using the quadtree. So first of all, I make this grid. So no grid is saturated. I will just go further. You see that few of the grid, this, and okay, like apart from that, no other grid is saturated. Okay, this is also saturated. So I will mark these 4 grids. Again, I go further. So the grid which is saturated, that will not be divided further. Can you see? So now so many grids are saturated, all the grids are marked over here. So you see this small feature is over the junction, that's why it will occupy all the 4 grids. So it happens. So again, you are dividing it further. So whatsoever grid is saturated, you are marking them here. Again, you are further subdividing and marking the grids which are saturated, and just if you go on reducing the size of the grid, you will be able to mark all. Can you see that in this manner, you will be able to mark all the areas. So what is the advantage? Now this particular area need not to be further subdivided. This area need not to be further subdivided. So that advantage will make this data storage in raster more compact. Already, now you can see. So data input, as we have discussed, that it can be from different sources in GIS. It can be manual digitizing or scanning. It can be data transfer directly from the GPS. It can be data transfer from CDs, hard disk, etc. And it can be direct keyboard entry. So your geospatial data can be prepared from any of these methods. So for manual digitizing, automated digitizing, you have got a certain type of features. I hope I have got that picture. So this is for scanning and this is for the manual digitization. We have done this manual digitization for several years. Nowadays, people don't do, they simply scan it and digitize on screen. So you see that sources of geospatial data are the digitized and scan maps, databases, tables of data. Sometime a particular data, this database or table is available from government agency, and very good example is Census of India. Census of India is preparing different type of attributes, and it is very good for geographers and other type of researchers. GPS provides the accurate location directly. The soft copy data can be input. Field sampling of attributes, remote sensing, and the aerial photography data. All these can be used. Then again, the sources, as we discussed, census data, maybe the hydrological data from different government departments. So that can be the topo sheet from Survey of India. It can be a traced map from the government agency like PW, etc. So like whatever be the source of data, you have to check whether it is useful at a particular quality level, etc. Then you can use. The satellite image can be used directly, or you can classify the satellite image and use the land use land cover. So this data output is prepared using that input data. So you can prepare the output by the ephemeral displays on the video display units just on the screen, or you can have a permanent images in the hard copy or paper. Like you can also prepare a map using your GIS software. So data integration can be done like these. All are the input data, which is just integrated in GIS, prepared a good quality map, and that can be prepared. So it can be a new information. It can be integration of the information. Now, as we discussed earlier, we will have some discussions about the topology. Topology is one of the very strong capability of GIS. And what we have in topology is basically about the relationship. So there are three types of topologies, although this topology concept is from the ArcInfo software, from the ArcGIS software. They are having the ArcNode topology. So what they have, Arc, is for line, node is for point, and polygon is for area. So they have got that topological features for all these type of geographical entities. So arcs have got directions and left and right polygons. So you have got a line, it may be of road. So with respect to the road, what are the different polygons on left hand side, right hand side? So what is the advantage? Suppose you have to broaden the road has to be widened. So which area should be occupied? Like what are the land parcels which will come in the road widening, and who are the owners of that? If you have all these type of information, then the task become very easy. So we say that it is the contiguity. Contiguity means you are moving and what is on the left and right side of things. So that information if you have, then the topology will become strong. Nodes link arcs with the start and end nodes. Suppose it is a river. A road can work in both the direction, but the river can work only in one direction. So the connectivity need to be established. Now the start node and end node need to be established in a very rigid manner. So all this type of information will be the part of topology, that how you are defining your nodes. And again, polygons. The arcs will form the polygons, and the arc that connect to surround an area define a polygon, that is for the area definition. So using this type of extra information basically, because you prepare the roads, you prepare the polygons, but this type of contiguity, this type of information is created when the arc, the GIS topology is created. All right. So basically what will happen? Each node has got its own table. These all are here. Each arc has got its own table. So from like arc A is having this starting node. This is the ending node. All the arcs, all the polygons are having this topology, that a polygon A is made up of 3 arcs, A, D, and G. And here also you will prepare that which for a particular polygon or for a particular arc, which polygon is on the left, which polygon is on the right. So this will create two type of topological structure. One is the spaghetti model. Spaghetti is like, you all have taken a spaghetti. Spaghetti is just like the noodles. So noodle, when you use, it will be just like a bunch. You just take it out, and whatever is your choice, you can take, or you can take it as a whole. So in the spaghetti model, what will happen? Suppose you have got two polygons. So for that polygon, you have got polygon 1 and the coordinates given to you. Please see that the starting and the ending, these coordinates are same. And you have got second polygon is on the side. So here also you have got the coordinates related to that, but we don't have any strong relationship between these. So if you have to go for a strong relationship, you have to go for the arc node type of thing. You see that vertices, all the vertices are marked over here. But as such, if you want to define the relationship, it will be difficult. So all the information is there. Can you see that all the information is there, but you are not able to prepare a relationship because, can you see here that your points, your like when the nodes are linked, you are just having, just again, can you see that here again the same nodes have been mapped because you don't have any relationship between polygon and polygon 2. Now we have got next type of topological model. In this topological model, we have got two polygons again, polygon 1 and polygon 2. We have got vertices of the polygon 1 as, can you see? All right, this is vertices for polygon 1. Next, vertices for the polygon 2 will be taken only as additional vertices. The previous vertices were not repeated. Look, these are the ones which are recorded. So now you are just marking the arcs for that. So how it has been marked? You have marked the nodes which are just having independence for that particular polygon. Now you will mark the node which is for other arc, for polygon 2. Look that the arcs which are common, they have not been marked because they will be mapped separately. So now they will be mapped for arc 3. So now the relationship for the arc 1, arc 2 and arc 3 will be established just in the form of your left polygon, right polygon. All right, so you see that these two are the nodes. So in this way, we call it as the arc node topology. And all these nodes are just marked over. And same type of data has to be stored in different type of table. First one is the polygon topology. Polygons are P1 and P2, which are formed by arc1 and arc3. P2 is formed by arc2 and arc3. And there is one more polygon which is taken care, that is the E polygon, that is the outside polygon. Some books, they call it as a U, universal polygon as such. Then the node topology, it says that N1, N2. So this N1 links the arc 1, 2 and 3. N2 links arc 1 and 2, 3. Node topology, you have got the starting node and ending node, as well as whatever is there as a left poly and right poly, they also you record. So when you have this information, then only you can link that these polygons, they will have this arc as a boundary, or this arc will have these polygons as a neighbor, like that. So all these type of relationships are established. Then the arc coordinate table. So for each arc 1, 2 and 3, the starting node, ending node and the intermediate vertices. So all these are recorded. So that is a real arc node topology, which will be useful for each type of. So with this, we have taken some fundamentals as well as some analysis related things. So I will be happy if there are few questions on this.
Any participant who is willing to ask question? Participants? I think, sir, you have like explained the session in a very ground rooted manner so that all the participants have basically learned everything. So, sir, there is
Normally,
some
it has
question
got
from
only two
Satish Kumar.
situations. Whether everything is understood, that is not possible.
Sir, both
And
the things are
second
possible.
condition is nothing has been understood.
Kindly unmute yourself. Some Redmi. Sir, one question is there.
Yeah.
Can we
It is in
generate
the-
3D or contour map through GIS?
Can you please repeat it?
Aman Bhatla has asked a question. Can we generate 3D or contour map through GIS?
Yeah, we can generate a contour map because GIS also helps in interpolation. All right. So you need to have good data for that. If you have good elevation data, then the contour maps can be generated. And basically, you know that DEM, digital elevation model in GIS, it deals with that. All right. So from the contour, you can prepare a DEM. From DEM, you can prepare contour. And maybe possible you have got few elevation values. So those elevation values can be interpolated in order to produce the contour as well as the DEM. It is possible.
Some participant is like registered with the name Redmi. Kindly unmute yourself.
Hello.
Hello. Yeah, please ask the question.
Good afternoon, sir.
Good afternoon, Ji.
It was a very good session, but some of the point I missed from physics background. I am from physics background.
Okay.
So how can I incorporate this GIS and remote sensing in my research? Linking to physics, if
Yeah,
sir can link.
I think you can choose a number of tasks in physics also, because physics is considered as a backbone of all type of sciences. So I think there will not be any doubt that you cannot include physics. Physics also deals with the spectrum, etc. So you know, in remote sensing and GIS, we have got a different type of spectra. You can study the sensor's capability. You can study how a particular sensor behave in a particular type of environment. You can link it with the atmosphere, etc. So here in geomatics, physics people can also have a lot of works to be done.
Sir, the spectral signatures play a very important role in identification of any object. So you can study the different spectral signatures, which are basically being like portrayed by putting a specific light on that particular object. So that can be studied in detail, and you can suggest these kind of things to applications for which we develop applications in civil engineer, architecture, urban planning, or any other environmental or any sciences. So you can always suggest such kind of spectral signatures from physics background.
Yeah.
Thank you.
Sir, somebody else has also asked a question. Aman Bhatla, can you unmute yourself? Amanji, can you unmute yourself? Sir, I'll speak the question.
Yeah.
How can we practice GIS maps like QGIS or any other tool that we have to practice?
He want to practice. What does he mean by practice?
The question is not very clear, Amanji.
I think he want to ask how he can use. So just in that other type of softwares, normally all these are at the same format. All right, there may be a slight different format in ArcGIS as well as Quantum GIS, but you can open the Quantum GIS file in this ArcGIS also. All right, so you can practice any type of GIS data from any source. Only thing is the attribute files that you have to take care. Like if you directly take the AutoCAD file to ArcGIS, some attribute problem is there. And again, you see your Quantum GIS, it takes the shape file. And nowadays, the ArcGIS, it takes the geodatabase type of structure. So you have to take care that same type of format are being used in both the software, and you can practice it.
There will be a special session by Professor Poonam Sharma from Delhi University. She'll take through QGIS module. So there you'll get to know more detailed version of the things.
Yeah.
They're looking at the time that we requested. So I really thank you very much from the bottom of my heart and for delivering the lecture on GIS fundamentals and analysis, which sets basically the tone, which basically sets which basically sets the tone for the entire course. And I'm very thankful that you have differentiated in starting of your lecture on GIS and then LIS, LIDAR systems, then what GIS is, the meaning, implications, and what they can do. So you have thoroughly explained these things. The level of abstractions have been explained, and more on that, how we can like the data and how we can change the data into information system. That has been explained thoroughly. The different file structures, database structures, topological data models, spatial data structures have been explained, and with the help of relational systems that can be detailed out. So I thank you very much, sir, for starting the tone, setting the tone of the entire FDP. And we look forward for the next session towards the end of the entire FDP, where we'll be setting the tone for the next faculty development program. So thank you very much, sir. Thank you very much for.
It's my pleasure. It's my pleasure. Thanks to everybody for the patient hearing. Thank you.
Thank you very much, sir. Thank you. To all the participants, will be joining back again at 2:15. So you can log in again at 2:15. Thank you very much. And the next session will be by Professor Bhagwan Singh Chaudhary from Kurukshetra University. It's a request to all the participants that you should like join with the name rather than the instrument name. Like the Redmi is there. Kindly join with the help of by adding your name instead of Redmi. There are many
Yes, sir.
others.
Yes, sir.
Yeah, kindly join with your name rather than the Redmi, the phone's name.
Okay, sir.
Thank you very much.
So how will we get the attendance, sir? Is it automatic?
It's automatic also. We'll be sending a feedback form also.
Okay, sir.
It'll be in both the way. If somebody misses some session because of the technical problems that we were having, let's say the participant limit was there. I was not aware that this limit is there. So I have asked the computer center people to upgrade this limit. So once it'll be done, by the time you can join by using the YouTube link, and we'll be like continuously monitoring the participants list in this online mode also, and automatic recording is also there. And more on that, will be like taking the feedback forms also, daily feedback form regarding all the speakers, because speakers have requested their feedback form. So we would like those feedback forms also, apart from the Atal, the formal mode that Atal has adopted. So we'll be taking the feedback forms related to the sessions also.
Okay, thank you.
Thank you. Somebody has joined with the name of the system Lenovo. Kindly change the name. Yeah, you can leave. You can leave. You can join back again at 2:15. We'll start the session at 2:30. Good afternoon, sir.
Good afternoon, Dr. Manoj. Am I audible?
Yes, sir. Yes, sir.
Thank
Please
you.
check your settings. We'll start sharp at 2:30, sir.
No issues. Thank you.
Okay, sir. Thank you very much. Good afternoon, everyone. Welcome to the second session of the day. Professor Bhagwan Singh Chaudhary from Department of Geophysics, Kurukshetra University, Kurukshetra, will deliver his lecture on understanding geospatial technologies. Regarding Professor Bhagwan Singh Chaudhary sir is currently working as professor in Department of Geophysics, Kurukshetra University, Kurukshetra, Haryana, India. He was chairman Department of Geophysics and chairman Postgraduate Board of Studies in Geophysics, Kurukshetra University from December 2017 to December 2020, and also held the position of registrar of Kurukshetra University from June to November 2020. He has worked as founder registrar of Chaudhary Bansilal University in the state of Haryana, Bhiwani, from 2014 to 2017. Sir is a PhD in science on integrated land and water resource management from University of Rajasthan, Jaipur, and MTech Applied Geophysics from Kurukshetra University, Kurukshetra. Professor Chaudhary started his career as a scientist in Haryana Space Application Center, which is basically HARSEC in Hisar in 1990s, and worked till 2004. He has worked on many research and development projects sponsored by government, industry sponsored projects in the field of geospatial technology. Professor Chaudhary was awarded DART Fellowship at University of Freiburg, Germany from 1997 to 1999. He got Best Paper Award at 18th IPRS Conference at Vienna, Australia in 1996. He is working in the domain of geospatial technologies for natural resources for about 30 years and has published more than 70 research papers in various national and international journals, conferences. he has worked on various teaching positions in Kurukshetra University starting from 2004 and supervised more than 10 PhDs. He is currently presently supervising 6 PhD scholars for PhD research. He is executive member of Indian National Committee, INC, of International Association of Hydrologists, IAH, and fellow of Indian Water Resource Society, South Asian Association of Economic Geologists, and the Society of Earth Scientists, and life member of dozens of national, international scientific societies, academic associations. He is a member of the editorial board, reviewer of more than a dozen prestigious national and international journals. He has co-edited 3 books entitled Application and Challenges of Geospatial Technologies, Potential and Future Trends, which is published in 2018, Remote Sensing and GI Sciences, Challenges, Future Directions, published in 2020, and Geostatics and Geospatial Technologies for Groundwater Resources in India, which is published in 2021 from Springer Publishers. He has visited many countries like US, UK, Australia, Germany, France, Netherlands, Switzerland, Poland, China, South Africa, Indonesia, Bangladesh, Sri Lanka, Nepal, and Thailand for various academic scientific assignments and conferences. He is presently executive editor of INC of IAH, online journal e-Journal of Geohydrology. He is member PGPUS Department of Geophysics, Kurukshetra University, and Geohydrology. He is member PGPUS Department of Geophysics and member of Board of Studies, Academic Council, Planning Board, Court, Governing Board of many prestigious universities and academic autonomous colleges throughout India. I welcome you, sir. And sir, over to you. Thanks a lot for accepting our invitation for delivering the lecture. I know informally also, sir, I know, sir, through lectures only. I have heard him thrice in different FDPs only. So I prefer to invite him because his talks are like very enlightening in the field of remote sensing and the advances in understanding geospatial technologies. Thank you very much, sir, for accepting our invitation. Over to you, sir.
Thank you. Thank you very much, Dr. Pawar and Dr. Kavita Rathi. I'm indeed thankful that you give me the opportunity to interact with our younger colleagues. I consider it as an opportunity because, these are the time when you try to connect yourself with the youngers in the field. And as we all know that today's time, is heavily dependent on the digitalization. And when we are talking about the, monitoring of the earth resources, then we say that geospatial technology is the prime tool. We are aware about the geotagging of different events. We are aware about that how the spatial distribution helps us in, devising and understanding the spatial distribution of the natural resources, that how these are distributed on the surface of the earth. We are having many phenomena which are taking place on the surface of the earth. And with the passage of time, these are having the dynamic concept, dynamic aspect, right? So if we want to monitor the changes which are taking place in the earth resources, then that we need to have the earth observation satellites, right? With the passage of time, with the increasing urbanization, increasing industrialization, population explosion, we are talking about the deforestation. We are talking about the climate change, right? So we are having a plethora of issues which the humanity is facing nowadays. So can there be any device, any technique, any tool through which we can really monitor the changes which are taking place on the surface of the earth? If we are able to secondly, prudently monitor the changes which are taking place, we can try to develop certain models. And after developing certain models, we can understand that how this is going to, a particular phenomena is going to behave in future. I will be just sharing my screen within few minutes. I just want to make a little bit background that why we are into this today. And I'm sure that your inaugural talk and the talk by Dr. Garg might have given you an insight that how the geographical information system with a plethora of capabilities can help us in devising certain plans, which definitely can help us in understanding not only the spatial distribution, but also managing that how the particular phenomena is going to behave in future. For example, as Dr. Pamar has already told you, that I will be briefly touching upon the geospatial technology. We'll try to understand why there is the need of geospatial technology, why at all such type of technologies are required. And then I thought that let me correlate it a little bit more towards the water resources, because now specifically you look to Haryana, and when we are looking at the global level, we are having many issues where the water is one of the commodity which is most stressed, right? So we will try to understand the distribution at the global level, at the continent level, then at the country level, and then local, that what are the major issues which we are facing in Haryana, and what can be the, when we are talking about the geospatial technology and any other intervention, I always, admire the people's participation. And we all know that nowadays, until and unless any, scheme which is coming from the government of India, or which is from the, district administration, until and unless we are having certain pertinent involvement of the people from the local communities, I think we may not be able to understand, and we may not be able to manage these things prudently, right? So with this brief background, I will be just sharing my screen, and I will request my friend Manoj to just give me a thumbs up when it is okay. I hope that
Sir, it's okay, sir. It's visible, sir.
yeah, I will just share it. Yeah. So is it visible?
Sir, it's visible. You can do the full screen, sir.
Yeah, I have done the full screen, Dr. Saab.
Sir, it's not full screen visible. It is not there.
Oh. Should I join again, or what can be? Because from my side, I have put it in the full screen mode.
Sir, it's visible, though it's visible. Although
So,
it's not in full screen mode.
yes, I have. Now I'm again, putting it in the, now I have put it in my screen. I'm able to see the full screen in the presentation mode. No?
No, sir.
So should I rejoin, or what should I don't know. I mean,
Sir, you can continue because it's visible, sir. You can increase the size of the slide by fitting it to the screen.
I don't know. I mean, actually, a few days back, I had a presentation as Himachal Pradesh University also, and there also they told that there is some problem that some of the speakers
Sir,
are
you need
not.
to share the screen again.
Okay, okay. Let me stop, and then maybe I will try
Yes,
again.
sir.
Right?
Yes, sir. Yes.
So I'm putting to the full screen mode. Now is it okay?
Sir, it's visible in the same mode, but it's still visible.
Oh, I'm sorry.
And you can
Should
kindly press F5.
leave and join once again? Will that do some?
Sir, no, it will work. This will work.
Okay,
It's
then.
visible, sir.
Actually, there are some presentations which I have put in a sort of animation mode. Then, if it is not in the full screen mode, maybe I may
Okay,
be.
yes, sir. Yes, yes, yes.
So I'm sorry, I will just take 1 minute more. I will just leave and then again join, right?
Okay, sir. Okay, sir. Okay.
Yeah, please bear with me.
FDP team kindly co-host, sir. FDP team.
Okay, sir.
Make sir as co-host. Yeah.
So Manoj, I'm again going to share my screen.
Sir, yes, kindly share.
So I have shared my screen and
Sir,
then
kindly press F5.
F5. Okay.
Is it in full screen mode to you?
Not yet. Yes, now it is in full screen.
Sir, from our side, it's not in full screen mode.
Okay. Then maybe I think without wasting the time of our colleagues, I can slightly increase the size.
Sir, yes, yes.
I don't know, will it work?
Yes, sir, yes. It's visible, sir.
Okay, because now I can move from like this, right?
Yes, sir, yes.
Okay, thank you. I'm sorry. Actually, at times these are the technical glitches.
Yes, sir.
As Dr. Manoj has said, that I will be primarily focusing upon the understanding geospatial technology, and then I will be talking about that how the geospatial technology can help us in water security at the global level. So in the morning lecture, you might have gone through about the geographical information system, what are the fundamentals, why we are using the GIS, and how the GIS is helping us in understanding various natural resources phenomena or natural phenomena, and how we can characterize these, right? So the term, if I talk about geospatial technology, as you see on your screen, that I say that it is the synergistic use of 4 different techniques. One is the remote sensing. Second is the geographical information system. Third is the global positioning system, GPS, and fourth is the information and communication technology. So if we try to synergize the application of these 4 techniques together, we say that it is the new technique, which we call it as the geospatial technology. Why we try to synergize and what are these different top techniques? I know that many of my colleagues are from diverse backgrounds, and many might be from the core field of the remote sensing and GIS. But I thought that let me take some time to introduce you to the various components, these 4 components of the geospatial technology in a very layman's language, in a very preliminary language. And then we will try to see that how these are going to help us in the Earth observation devices, right? So when I'm talking about the remote sensing, as we all know, that we are talking about the features which are present on the surface of the Earth. We want to observe, we want to map, we want to manage, we want to monitor these features which are present on the surface of the Earth. As a layman, we know that all the objects which are present on the surface of the Earth are having the different thermal capabilities, the different thermal properties. What do I mean by different thermal properties? That the amount of incoming solar radiations which is falling on the surface of the Earth, which is having different features ranging from the glaciated mountainous regions and the forest area. Then you are talking about, say, sandy area, you are having some water bodies, you may have some cropped areas, right? So we are having the different objects which are present on the surface of the Earth. And the amount of light which is falling on these features will either be absorbed, transmitted, or reflected. Right? When we are talking about the optical remote sensing, or the normally in the normal usage, we talk about the remote sensing, we are talking about passive remote sensing. What do we mean by passive remote sensing? That sun is the source of energy, solar radiations are falling on the surface of the Earth, and we are having some devices which are remote sensing, which are at a distance from the surface of the Earth, are not in physical contact with the surface of the Earth, meaning thereby that these can be either handheld, these can be airborne, or these can be spaceborne. When I'm talking about the spaceborne, I'm talking about satellites. When I'm talking about the airborne, I'm talking about the drones, I'm talking about the aircraft. When I'm talking about the groundborne, I'm talking about the spectroradiometers. Right? So we may have the sensor in any of these devices, and as the word connotes, remote sensing, sensing from remote, acquiring, gathering information about the features on the surface of the earth from the devices which are not in physical contact with these objects or with the surface of the earth, right? And the advantage is that we are trying to gather, we are trying to differentiate the features which may be inaccessible to us, which may be beyond the visible region of our visible range, right? Our eyes, our eyes may not be sensitive, or we may use certain devices, certain wavelength ranges for which particular objects are having the sensitivity, right? So having these devices at the in the air or at in the space, whatever reflected light is coming, that is recorded by the sensors in the satellite or in the aircraft, and then the information is being transmitted to the data reception center, and then it is processed. Preliminary processing is done, and then the data is supplied to the user department. For example, I am a user at Kurukshetra University, and I want to carry out some projects related to the remote sensing and GIS applications in my area, right? So why? There must be a natural question in the mind that why we have to go for the remote sensing. As I have slightly touched upon, that we are talking about the platforms which are in the air or in the space, meaning thereby that we are having the minimum hindrances to the actual traversing on the ground. Right? So we are having the continuous monitoring of the features which are present on the surface of the earth. So the advantages are that we are having the synoptic view, means we can see the larger area at a glance. And what will be the advantage of this seeing larger area at a glance? That if there are some regional features which are present, we may not be able to see if we are seeing only a particular portion of that particular area. But if we are seeing the regional trend, then we will be able to see those features clearly. For example, if I say the paleo channel, right? So if we are seeing only a smaller area, we may say that this is some, area which is having a different reflection. Then the areas which are inaccessible. So we can cover the areas which are inaccessible. So we want to go for the glacier monitoring. So we want to get the information about that. Very important that it is a permanent record amenable to reinterpretation. As you might be knowing that nowadays that the remote sensing data is also being used as the evidence in the court of law, right? So it is a permanent record. You take a data of say 1972, the first Landsat satellite by US was launched in 1972, and take a data of say the Murthal area. So, or the Sonipat city. So we will be able to see that what was the extent of that particular city. And if we are taking the data of today, and then we can see that how the changes have taken place. So it is a permanent record. We can interpret any point of time. It is a multispectral data. Maybe at a particular wavelength, two different objects may reflect similar. So if we are using the multispectral data, we will be able to better differentiate these things. It is accurate and true picture, or it gives accurate and true picture of the terrain features. Many times you might have seen that, there are certain phenomena, for example, flood, where we are depending upon the data from the line agencies, for example, the revenue department. And many times there is subjectivity in the supply of the data, right? So, but if we are having the cadastral level data, and we can overlay our, you can say the Khasra and Khatoni, on that we can even identify the individual lands which are affected by the flood. So it gives accurate and true picture of the terrain, multi-day data. As I was discussing in the beginning, that when we are talking about the Earth observation devices, the beauty of Earth observation devices is that these can monitor the dynamic changes which are taking place. We are talking, as I talked about Sonipat city. So how much was the expansion in 72, 82, 92, 2002, 2012, and 2021? So we can monitor these with the passage of time. So if we want to plan the scientific management of the city, by 2052, how much will be or 2030, how much will be the expansion of the city? Then you have to go for the utilities mapping. So these type of things are very, very important. Then updation of information is possible. That when we are talking about the information which is already available in the form of maps, many new features have come up. Satellite images help us in that. It is cost and time effective. Maybe, I mean, some of us can argue it at this point because the satellite launching also costs a lot of money. But if you see the usages in the multi-dimensional areas across the disciplines, then you will definitely see that this is one of the very, very important area where we can say that it is cost and time effective. Because when we are talking about the natural resource management and sustainability, there is no, these are invaluable. The natural resources are invaluable. So if we are having any devices which help us in monitoring these, I think it would be one of the very, good from the point of view that we can monitor these in a very good way. So when I'm talking about in the optical satellites and a little bit, that what are the satellites which are available in the optical range? You all might be knowing that India is the pioneer in the applications of geospatial technology. America started, Russia, France, and we can say now India is also second to none in the applications of advanced technologies. And specifically, when we are talking about the spatial resolution, or when we are talking about the spectral resolutions or the radiometric resolution, which is in the range of 2 to the power 10 now in the Cartosat 3, right? So you can see that the beginning was done in 1988. I'm talking about the commercial satellites later, I'm talking from 1970s. So IRS 1A, 1B, we were having the resolutions of 72.5 and 36.25 meters. With the passage of time, we have come to Cartosat. And can you see here in the Cartosat that we are having a spatial resolution of Cartosat 3, which is in the range of 25 centimeters. So any feature which is present on the surface of the Earth of the size of 25 centimeter by 25 centimeter can be picked up by the satellite, and it can be divided into 1024. We are having the features which are present on the surface of the Earth. We can have as many as 1024 different classes when we are going to classify that, right? So starting from a medium level, like 72 meter coming to 25 centimeters is really a good move. And then one of the major problem, as all of you might be knowing, that when we are talking about the optical satellite, one of the important problem with these optical satellites, one of the main problem is that if we are having the cloud cover. So what will happen when we are having the cloud cover, that we will not be able to get the data of the surface of the Earth, right? So if we want to monitor something, we will not be able to monitor. Then ISRO decided that let's go for the satellites which are operating in the microwave range. What do we mean by microwave range? In the range of 1 millimeter to 1 meter. Why microwave? Because microwaves are having the capabilities to penetrate through the clouds. And when these are penetrating through the clouds, so it is in a way giving us 24 all-weather capability. It is giving us all-weather capability. So we are happy as a nation that ISRO has come up with radar imaging satellite in 2009, RISAT 2, and then RISAT 1 in 2012 and RISAT 2B in 2019. So now India is having a combination of both the optical as well as radar imaging satellites. So as a nation, now you are having the all-weather capabilities. So when we are talking about the imaging capabilities of our nation, we can see that we can have the capabilities which are ranging from as coarse resolution as 1 kilometer. So we can only have some reconnaissance in information to less than 1 meter. And we are having you can see less than 1 meter, we can go for the cadastral level mapping, city level planning, utilities mapping, right? So like the Cartosat 3, 25 centimeter by 25 centimeter. We can go for the utilities level mapping in the cities. So for the preliminary information, reconnaissance type information at the continent level, at the national level, 1 kilometer may be good enough. But then when we're going for the state level or the district level planning, maybe 72 to 36 can suffice. But when you're coming to the city level planning, right, planning at the city level, then you require the spatial resolution less than 1 meter. So when we are talking about the repeativity, it is one of the very important aspects when we are talking about the changes. So it may range from 24 days to 30 minutes. And the scales we can operate upon is from 1 million to the cadastral level, 1 is to 5,000, 1 is to 3,000, 1 is to 2,000, right? So this is where you as a nation stand today. Now, as you know that with the passage of time, again, the use of drones has increased, and it is, ranging from your municipality tax to disaster management and so many. So, I mean, there are so many wider applications. It is another aspect of the remote sensing, which is added to give you the better spatial resolution. GIS, I will not be touching upon because you already had the class today morning. And as you know, I would like to just say that when we are talking about the geographical information system, whatever we are getting, we are deriving as output from the remote sensing. We are preparing certain maps, right? All those maps are acting as input into the geographical information system. Then we can give some complex or the simple queries to prepare certain plans, certain derivative maps, so that we can really not only make the management of the natural resources better, but also nowadays you might be knowing that you talk of the transportation, you talk of the utilities management. GIS is an inherent component in that, right? And one of the beauty of this is that we can identify the locations within a targeted environment which meet a specific criteria. I will just take 2 minutes before we proceed further. That for nowadays you might be knowing that we are having a lot of issues related to solid waste management, right? And one of the I will say that one of the important technique which really helped in this direction is the GIS. If we are having a number of map which relates to the transport network, to the land use, land cover, that which are the areas which are lying waste, and then the soil, that what is the type of the soil in different areas, texture, soil texture, which helps us that in the case of the solid waste and the rain, in the event of rainfall, the leachate does not percolate down quickly so that the groundwater is polluted. Then we are talking about the depth to water level, because if it is shallow or moderate, there are chances of the pollution. Then we are talking about the slope, right? And when we are having all these maps together, we can give a query that I want to identify from land use, land cover, it is a wasteland. The area is more than 5 hectares. Then from the transport network, that it is not beyond 3 kilometers from the periphery of the city. From the soil, I'm taking that it is either loamy or the clay type of the soil. Depth to water level, it should be moderate or deep. When we are talking about the slope, it should be moderate. So transportation cost is not increasing, right? Or it's low. Then putting these queries into the GIS with the database, then you will identify that, yes, this is the location which meets specific criteria. Land use, land cover, I'm not going to use the fertile agricultural land. I am looking for a patch of wasteland which is beyond a particular size, right? So these type of quite important applications are there with the GIS. So you know that when we are talking about the GIS processes, it ranges from the measurement, mapping, what are the similar looking features, putting these together, monitoring with the passage of time, how it is changing, right? And then modeling that the city the expansion of the city in 72, 82, 92, 2002, 2012, 2021. Then predicting, modeling, predicting for the future that by 2030 or 2050, how much will be the expansion of the city. Right? Why we want to do that? Because you want to have the scientific management of the utilities, how much electricity will be required, water will be required, what type of different amenities are required, all these type of things. This will help. And nowadays you might be knowing that even ranging from your water supply to your seaways to your gas connections, everything, all the utilities are now being monitored with the help of the GIS. Then GPS. All of us, most of you are engineers, some are students, some of my colleagues are across the disciplines. So what I would like to say that we all know that GPS, it is a position locator. Position locator, I want to know the latitude, longitude, and altitude. And one of the important application of the global positioning system is the navigation. And you can understand nowadays that whenever you are talking about the Uber, you are talking about the Ola, you are talking about your self-navigation to an unknown place. We are just, putting the navigation on and then we are able to use it. So it is one aspect. But when we are talking about the natural resource management, location, that too, the accurate location is very, very important when we are talking about the management of the natural resources. So when we're talking about the GPS, we all know that it was initiated by the United States in the form of Navistar GPS. And when we're talking about the space constellation, we say that we are having the 6 different orbital planes, and we are having 4 satellites in each orbital plane. Arrangement has been made in such a way that these orbital planes are at an altitude of 20,200 kilometers. And their orbital period is 12 hours. These are made in such a way that on any point on the surface of the Earth, if you are having a GPS navigator, a GPS instrument in your hand, if you go out, you must have at least 4 satellites in the view. Why? X, Y, and Z, latitude, longitude, and altitude is the precise location, and 4th is for the time correction, right? So this is the US version. What happened actually, India as a nation, when we are talking about these type of the applications, military is one of the pioneer in using it for the strategic applications, right? So it was observed that in 1996 during the Kargil war, there was problem related to the accuracy of the GPS signals. Then the government of India decided that we must go for our own initiative, and Indian initiative is in the form of GPS and geo-augmented navigation, GAGAN, right? And it is spearheaded by ISRO in association with the Airports Authority of India. So both the Airports Authority of India and the ISRO are joining together, and we are having 8 reference stations across Bangalore, Ahmedabad, Calcutta, Guwahati, Jammu, New Delhi, Port Blair, Trivandrum. And you will be happy to see this slide on your screen that India is having only 7 satellites in the form of, all of you might be aware, IRNSS, Indian Regional Navigation Satellite System, right? So under the IRNSS initiative, we are having, this is your IRNSS 1, this is 2, 3, 4, 5, 6, and 7, right? So these are made in such a way that these are number 1 geostationary satellite. Previously, you have seen the Navistar GPS. These were at a height of 20,200 kilometers, but ours IRNSS are the geostationary satellite, meaning thereby we all know that 36,000 kilometers, and these are synchronized in such a way that these are continuously looking to the same portion of the Earth, meaning thereby that relative speed of both the rotation of the Earth and the revolution of the satellites are synchronized in such a way that these are continuously looking to the same area, so that uninterrupted services, uninterrupted services can be delivered, can be provided to the people in that particular area. When we are talking about, that GSAT satellite or INSAT satellites, we are talking about the DTS services, we are talking about the mobile telephony, we are talking about search and rescue navigations, we are talking about the weather forecasting, for example, right? So this is the geostationary. And interestingly, that 1500 kilometers beyond the borders of India, we will be able to have the precise location, meaning thereby that in the event of strategic conflict, kindly underline this, in the event of strategic conflict, the government of India, with the help of this IRNSS, our military will be able to get the precise locational access with the help of the IRNSS. So we need not depend on any of the foreign nations. So as you all are aware that when we are talking about the launching technology, India is able to develop the workhorse like the PSLV, you are having the GSLV and the SLVs, different satellite launch vehicles. India is successful in having it state-of-the-art applications. Then when we're talking about the Earth observation devices, you may talk about the Earth observation satellites in the form of the optical satellites, IRS or Cartosat. Then ResourceSat, you are having multiple applications for surface temperature, sea surface salinity, and then monitoring the sea phenomena or the ocean phenomena. And then coming to the GPS, now you are having the own GPS. And then the fourth component of the geospatial technology, we all know, and I will not be touching upon much on this, that we call about the information and communication technology. You have prepared a number of maps, right? All those maps needs to be shared. All those dimensions which are available there needs to be accessed. We may be a group of scientists working across the countries, India, Japan, US, Russia, Germany, and we all are dealing with one or the other aspect of that particular project. So we want to share the information in real time, right? So now you are having the web-enabled GIS, you are having the virtual, you can say GIS, you are having the lot many, applications where the advantages of ICT are inbuilt and the power of the computing capabilities are embedded, and we are having these these applications which are coming handy for the natural resource mapping and management also, right? So the ICT in a real time, in a cost-effective manner, in a very prudent way, we are able to share the information at the click of the mouse. And then that's why it is providing us many opportunities where the cost is being reduced, and the sharing has become very, very fast and very easy. So we can say that ICT is for the real-time information on various issues concerning with the Earth resources mapping and management. So that is another very, very important aspect. There is a word of caution, and we have to be very, very, we have to be very, very cautious about that. And this word of caution is that when we are talking about these applications, there is, that there is a terminology known as GIGO when in the computer science. GIGO, garbage in, garbage out. What does it mean? That when we are dealing with the digital technologies, we have to be very, very authentic. We have to be very, very sure about the input we are putting, because whatever applications, whatever analysis, whatever classification you are doing, all those may not be able to remove that inherent error which was during the acquisition. So you have to be very, very sure about the authenticity, about the accuracy of the input data. So if you are not sure about the accuracy of the input data, you cannot be sure about the output which you are generating. So it is very, very important when we're talking about the geospatial technology, right? And one more thing, that whenever we are talking about these digital technologies, this is very, very important, that it is making the life of the people easier. Whatever focus today we are seeing, all this is nothing but we are talking about, we are thinking about, we are planning to make the life of the people easier. So this is the information and communication technology. Now, you can see that when we synergize the remote sensing, GIS, remote sensing, Earth observation devices, we have prepared number of maps, put into the GIS, we are making the decision rules. We are using the different decision support systems. We are preparing some derivative maps. Because GPS is the location is very, very important when we are talking about all these geospatial aspects. So we are having the GPS data which is available to us, having the highest accuracy, and then the real-time sharing, information and communication, effective sharing, cost-effective sharing, right? So we are using information and communication technology. Nowadays, you might be knowing that GIS, Geographical Information System, now is more talked of at GI science, because it is becoming almost embedding all the latest advantages of the digital technologies which are available to us, right? So this, in nutshell, you can understand that when we talk about geospatial technology, we talk about a combination of these 4 different technologies. Just an overview about what are some recent missions of the Indian Space Research Organization. You can see 2019 across 20 and 21 that we are having the Microsat, Kalamsat, AMISat. The latest is the Amazonia, right? We are having a number of satellites which are helping us. You see here RESAT. We are having the RESAT 2BR1 on December 11, 2019. And we are having these satellites RESAT 2B, May 22, 2019. These are some of the combination of the satellites which are making us powerful in the utilization of the Earth resources in a better and prudent way. Now, when we are talking about the application, Dr. Pamar has, very precisely and judiciously, managed to connect all the applications of the geospatial technology. And I was able to see that he has invited a number of resource persons across the institutions. We will be talking on various aspects of the geospatial technology. But just to start with, you can see that you talk of any area. You talk of agriculture and soils, you talk of forest, environment and bio, you talk of the water, maybe the surface water or the groundwater, you talk of disaster support system, you talk of the ocean, you talk of the weather and climate, you talk of the land, means land use, land cover. So you talk of ocean, you talk of land, you talk of weather and climate, you talk of the agriculture and forest, right? So we are having the applications there, right? When, because, these techniques which we have discussed till now, these techniques are having such applications and such implications that these are the inherited advantage when we are talking about Earth observation applications. And nowadays you might be knowing that with the coming of the Sustainable Development Goals, SDGs, the geospatial technologies are becoming the key for everything, right? So I will be taking you through one of the applications which I think is very, very important when we are talking about these applications. That will be the water. And when I'm talking about the water, I will take you through, please take it as a prelude, what I'm going to discuss today, and some of the applications, please take it as a prelude to your this FDP. And I'm sure that what we will be discussing today will definitely give you an insight that in the coming time, in all the follow-up lectures, you will be able to extract more and more when you are having this prelude available with you. And in that way only I have put this phrase lecture. So why should we talk about water? Because water is now becoming a global crisis. So if it is becoming a global crisis, and you might be knowing that in 2019, Cape Town would have been the first city to be deserted because of the water scarcity. We have seen in India in 2019 and 20, you talk of Chennai, Bangalore, Hyderabad, were facing the dire shortage, the acute shortage of the water, right? So I thought that let me precisely talk about how the global scenario related to water is there, and then what are the problems at the country level. And then I will be taking you to Haryana, because Haryana is one of the important agricultural state, which is contributing sufficiently to the national kitty of the food grains, right? So you will be able to understand that these issues are not only confined to Haryana, but also across the states. So when we are talking about the water, at the global level, every fourth person will not have safe drinking water by 2050. It's really, we cannot imagine. 5 million people die of unsafe drinking water every year. By 2032, 50% population will be forced to live in areas of water scarcity. Every year second, one child dies of waterborne diseases. 20% of the species of fishes found in the fresh water areas became extinct. Agriculture uses the dominant portion of the water use. It's about 69, it depends from 69 to 75% of the total usage of water is in agriculture, 23% in industry, only 8% of the household. Here we have to be very, very sure. And you might be aware, many of my engineering colleagues, that nowadays we are talking of the yield per liter instead of yield per hectare. And that level of awareness has to come. We as a nation are still far behind when we are talking about the irrigation efficiency. I will be discussing in the following slides. And you can see that when we are talking about the earning, there is an earning of $30 billion for providing safe drinking water. So that all at the continent, at the global level, makes us ponder upon that we must be very, very sure about the proper usage of the water. We have to think about the abuse, misuse of water which is going on. I mean, as you can see from here, that every year second, one child dies of waterborne diseases. That's really pathetic. So why at the country level, we must talk about the water? You can see that India is also in a disadvantageous position when I'm talking about the natural distribution of the freshwater reserves. You can see this slide. It is the global population distribution versus freshwater reserves. And I'm talking about at the continent level. You see the North and the Central America, they are having only 8% of the population and they are housing 15% of the water resources. Europe, only 13% of the population, 8% of the freshwater resources skewed. When you're coming to the North America, South America, we are having only 6% of the population and 26% of the freshwater resources. And when we're talking about Africa, we are having 13% of the population, 11% of the water, little bit skewed. Europe, we are having little bit, the disparity. But when we are talking about the Australia, they are having only 1% of the population. They are having 5%, 5 times the freshwater resources which are available over there. But if you come to Asia, can you see that we are having housing 60% of the population and we are having only 36% of the freshwater resources. So as far as the natural distribution of freshwater resources is concerned, we are in a very, very disadvantageous position. So you can see that whatever is being talked of, we have to be very, very careful about planning and managing our water resources which are available to us. And you can see that in many of our, you can say the religious text and the spiritual, or the social reformers have time and again, made the people aware about the use of the water. As you see here, Rahiman pani rakhiye bin pani sab soon, pani gaye na ubre moti manus. भागीरथी पुकारती सुन मानव नादान दूषित करके डालता खतरे में पहचान. So not only about the availability, not only about the importance of water, but also about the pollution which is taking place. So it has been rightly that Mata Bhumiha Putro Aham Prithvyah. Mata, Bhumi, Mata hai, and Earth is like the mother, and I'm just like the son. So we have to protect the natural resources which are available to us in a prudent way. So that cannot be, underlined anymore. We can give as much emphasis as possible, even then it will be less. So when we are talking about the Indian scenario, you can see that we are having only about 2% approximately of the world geographical area. We are having about 4% of the world water resources, and we are having about 19%, 18.74 or 18.84% of the world population. So you can see that we are again in a very skewed position. We are having only 4% of the world water resources. Now, though it was not enough, you can see that when we are talking about the utilizing capabilities, India is able to utilize only 12% of the annual estimated rainfall. If we say that 4,000 billion cubic meter is the total rainfall across the country, as of now is the present infrastructure, the country is not able to utilize more than 12% of it. So that has to be increased. I was talking about the irrigation efficiency. India is the country which is having one of the lowest irrigation efficiency. It's about 35%. What does it mean? That if we are putting in 100 liters of water into the agriculture, we require only 35 liters, right? So that is how it has to be managed. The 65 liters of the water is either going as a return flow or is going in the form of transpiration. So we have to be very, very careful about this. And again, you see that we are having the declining capabilities. Can you see the per capita availability of water has reduced from 51,000 cubic meter in 1951, and now it is about 1,486 cubic meters. And can you imagine that if it is less than 1,000 cubic meters per capita per annum, then we will be in the water stressed conditions, right? So we can see that in the coming time, it may escalate into the water stress conditions. And though as it was not enough, we are having many areas where the groundwater is being overexploited. So this is the scenario presently. So we will see that how the geospatial technology can help us in minimizing the ill effects or whatever the scarcity is there. So how we can manage it. And you can see that this is from Water Resources Information System, that per capita availability of water by 2050, it will be somewhere around 1,100 cubic meters. So it's really one of the worrisome phenomena. And when we are talking about the water stressed regions, you can see that almost we are having the dominant, those agricultural states which are available over there. We are having the situation from semi-critical to critical going to overexploited, right? So this is from the Niti Aayog. Right. When I'm talking about Haryana and Punjab, we can see that we are having the areas which are mostly the overexploited, and at places we are having some salinity problems also. So now I will bring you to my place, our state of Haryana. Many of you might be aware that Haryana is one of the states which is very important agricultural state, agriculture dominating state, and we are having the issues as any of the other agriculture state may have, like declining trend of water table in the fresh groundwater quality areas. Wherever the quality of groundwater is fresh, the water table is continuously going down. Why? Because we are taking more and more and more water out. One. Second, we are having the uprising trend in the central portion of the state. You talk about Rohtak, Jhajjar, Kaithal, Sirsa. These are the areas, Jeend, these are the areas where the groundwater quality is poor. That's why the problem of salinity waterlogging is there. The farmer is not taking the water out. We are adding the water through the canal irrigation. The water table is continuously coming up. We are having the meager availability of water in the surface water in the southern Haryana. In addition to that, always we are having the problem related to improper usage of rainwater, which causes floods in Yamuna and Ghaggar. Both Yamuna and Ghaggar, because of the encroachment, the Ghaggar has become almost a rivulet. very, very narrow courses there. In Yamuna also at many places you will find that we are having a lot of, encroachment, lot of excavations and mine excavation is going on, changing the course entirely. Then one of the very, very important offshoot of the green revolution, I will be just discussing that the heavy use of pesticide, fertilizers and industry. We are having the problem of industrial effluents also. So this is continuously stressing the quality of the groundwater. And then we are having the insufficient water recharge measures. Just to show you that how from the satellite our state look like. This is your Rabi season, this is your Kharif season. In the west, you can see the dominance of the arid, that is the sand dunes, this mostly the fallow land, right? And red is the agriculture crops. In the north, we are having the Shivaliks, the foothills of the Himalayas. And you know that Haryana is one of the states which is proud to have the youngest mountain system and the oldest mountain system. We are having the Aravallis in the south, and we are having the Shivaliks, lesser Himalayas in the north. And you can see that these, I will show you a little bit later also, that in the south we are having the presence of the Aravallis. You have the Yamuna, which is making almost the eastern boundary between UP and Haryana, and we are having the Ghaggar almost making the western boundary, right? Not exactly the boundary, it is passing through the western districts, right? So just to show you that how it looked like, and you see the physiography, we are having mostly, these are the alluvial plain, because Ghaggar and Yamuna alluvium is there, and these are the Aeolian plains, sandy influence is there, right? You are having the Shivaliks, I was telling you, and now you can see here very clearly, we are having these are your Aravalli hills, all these Aravalli hills, right? And here we are having the Shivaliks. Right? Now, one of the very peculiar aspect, this is little bit old data. Now this stage of groundwater development is somewhere around 129%. So when I'm talking about, you can see, sorry, just a moment. You can see down that when I'm talking about the quality, you are having the problem salinity, fluoride, chloride, iron, nitrate, all these problems are across the districts in Haryana. But I would like to focus on the stage of groundwater development. That in Haryana now, the stage of groundwater development is around 129%. What does it mean? That if I'm, recharging 100 liters of water, I'm taking 129 liters of water out. And this is leading to many of the situations I have seen in Kaithal district from 1974 till 2014, the water table in many areas has gone down to almost 30 meters. In these 40 years, the water table has gone down to 30 meters. So that is how your crop and wheat cropping system, the crop rotation is really, creating the problems related to the groundwater availability, the stress on the groundwater, which is over there. You can see that when we try to manage the aquifers, right? This is your Punjab, this is your Haryana, you join together the groundwater contours, right? Depth to water level, it's across the state. Right? What I mean to say is many times we have to be, when we are managing these natural resources, we have to think across the political boundaries, then only we can really prepare certain viable plans for the management. Why this groundwater table is going down? What is the reason? You can see here that I have just tried to put in the number of tube wells. 1966-67 is a very dear year. 1966 is a very dear year to me. There are two reasons for that. One is that Haryana was carved out in 1966. And another reason is that I was born in 1966. Right? So that makes it very dear, very, very important year for me. At that time, the number of tube wells was just to 25,311, both the tube wells and the pump sets. In 70-71, it became 104,000, 75-76, 2 lakh, 3 lakh, 4 lakh, 5 lakh. And can you see now also in 2017, 2021, it is somewhere around 8,50,000. Not remarkable increase is there. So almost the same, right? So we are having about 8,50,000, but you see the geometrical rise. You see from 66, 67 to 25,000 to more than 8,50,000. So this is one of the reasons where we are just the water we are just taking out, and we are not able to sufficiently recharge it, right? And this is the prime reason is that we are having the wheat and paddy rotation. What do I mean by wheat and paddy rotation? That we are having the continuous cropping system, which is taking more and more and more water out, right? And we are not able to recharge it. Right? So you can see this is emphatically clear from this phenomenon also. And then I was talking to you that Green Revolution in 60s, Haryana is one of the state which has, really taken the advantage of the Green Revolution, and Punjab, Western UP as well. But if I introspect today, what happened because of this? Green Revolution was emphasizing on intensive agriculture. We wanted to increase the agricultural productivity. We want to have the highest cropping intensity, right? So we are having wheat and paddy rotation, as we consider that these are the crops which are giving us the important economic returns, right? So what is happening that for having all this, having the highest production, we were using higher dose of the fertilizer and pesticide. In Haryana, you talk of any side, herbicide, pesticide, weedicide, insecticide, right? We are using all that. In addition to that, we are using the fertilizer. Every year, where we are enhancing the dose of the fertilizer because the soil is becoming incapable. What is happening? Because of the higher use of the fertilizer, we are having the problem of soil degradation. And then soil degradation is leading to the problem of lesser productivity. Again, we are using more fertilizers. And all these sites, along with the fertilizers, are putting a lot of emphasis on the water, are putting a lot of stress on the water quality. So we are having the continuous problem of water quality deterioration in these areas. And then environmental degradation, of course, when the soil degradation is there, the soil capability and soil suitability is being compromised, and we are having the compromising of the environmental parameters also. And then we are having the over exploitation of the groundwater, as we have seen previously. Looking to this, the government of Haryana in 2008, they said that in Haryana, we are going to ban a particular variety of the rice that is known as Saathi. And many of you might be knowing that this is a short maturing crop, which is grown in the summer season. And when you are growing the rice in the summer season, you can understand that how much water it will require. So that one aspect was, it was done in 2008 and Kurukshetra it was declared. And now the present regime led by Sri Manohar Lal Khattar ji, the present government, they have started a scheme to incentivize the farmers. That if a farmer is going for diversification, if a farmer is going to use his land, which was being used for the paddy, instead of paddy to the maize, then the farmer will be compensated about 7,000 rupees per hectare. And they will be provided free of cost maize, high quality maize seeds by the government. Why so? You can see that in Haryana, we have got from 1.92 lakh hectare to almost 13.5 lakh hectares of the area which is under rice. And you can understand that the 1 kg of rice production, I will just discuss with you the water footprint of different food items. 1 kg of rice production takes somewhere between 2,000 to 5,000 liters of water, right? And you can see that this scheme which was introduced in the name of Mera Pani, Meri Virasat. The government of Haryana has introduced this scheme that instead of going for the paddy cultivation, if a farmer is going for the maize cultivation, then the farmer is going to be compensated with 7,000 rupees per acre will be given as compensation to the farmer. And this is to consider the groundwater as a heritage. We are talking about the sustainability. in the coming time that the water which is available to us, can we utilize it prudently so that the water is not only, suffice for the present agricultural system, but the future generations will also be able to meet their requirements. And this type of anxiety was rightly shown by the Niti Aayog also. If you see this slide, that I have put it knowingly, the 2020, that it was said that many Indian cities will run out of groundwater by 2020. And we have seen the example of the Chennai and the Bangalore, right? That many of the IT professionals were asked to work from home. In India, 75% of the domestic water sector and 80% of the agriculture irrigation depends on the groundwater. So the groundwater is becoming more and more stressed. And not only at the country level, at the international level also, as I have discussed with you in the beginning of my lecture, that Cape Town would have been the first city to be deserted because of non-availability of the water. But because of the timely rains and the rationing which was introduced by the government of South Africa, they were able to save it. You can see that when we are talking about the composite water index scores, Haryana is not faring really well. It is one of the low performing states, right? Whereas you can see some of the states like Gujarat and Madhya Pradesh, where you can see that these are some of the high performing states. So when we are talking about the water, it was not that the state government was only worrying, that you can see the National Water Mission also, and they rightly emphasized that we have not only to focus and identify and include the people from different walks of life, but we have to increase the water use efficiency by 25%. What I was talking to you about irrigation efficiency, that we are having somewhere around 35%. We have to increase by another 20% by 2035. And water cannot be considered as an individual parameter. So we have to think about the basin level integrated water resource management. Basin level. We cannot deal it, we cannot manage it in isolation. We have to consider basin as a unit, a watershed as a unit, then we have to think about this. And we must have the comprehensive water database in the public domain and assessment of the impact of climate change in the water resources. You might be knowing, and you might have read that recently a CAG report is there, which is saying that there is a huge difference between the groundwater quality and the data availability at the state level and the central level. There is a huge gap. So this gap is somehow not helping in managing the resources in a prudent way, right? So that is another very, very important aspect which needs to be considered. And it has to be all the, the issues had to be citizen-centric, and we must conservation, augmentation, and the preservation of the water resources. So I was talking to you about the Sustainable Development Goals, and you can understand by now that when we are talking about these different aspects, which I'm talking till now, that the prudent management, the better management will lead to somehow achieving the target, which seems to be very ambitious, that transforming our world by 2030. That is the goal of the SDG. And one of the goal number 6 is the clean water and sanitation. We are talking about, I have participated in 2 events in Germany before COVID. One was, targeting zero hunger, that can there be, how the precision farming can help us in increasing the production and minimizing the wastage, and then thinking about the no poverty. Education is another area, but we will be focusing more on the water and sanitation, right? I will not talk much about, you all know that when I'm talking about the different global environmental issues, these ranges from the degradation, deterioration in the air, water, soil, and land pollution, global warming, climate change, so on and so forth. But we will be talking about the natural resources depletion. So what I was talking to you about the water footprints, if you see here, that when I'm talking about where is rice? 1 kg of rice is somewhere around 3,400 liters of water, right? And if I'm coming to where is maize, if you are able to see 1 kg of maize is requiring 900 liters of water. So that is why the government of Haryana, they focus that if we, I'm sorry, I will just take a minute. I will take. Right. So if you are able to focus here, that the rice 1 kg, somewhere in between 2000 to 5000 liters of water, whereas a maize requires only 900 liters of water. So we have to think in terms of but again, there are the eating habits and other issues which cannot be compromised upon. So how to deal with all those issues, but just to have an idea about, you see here that chocolate, 1 kg of chocolate, preparing 1 kg of chocolate requires about 24,000 liters of water, right? And you can see that beef, 1 kg of beef requires 15,500 liters of water. So we can see from here that we are having many of the products which are available over there where the water footprint is really high. So can there be any possibility that there can be some change in the pattern of consumption, if at all possible? So why and how water security? Water security cannot be understood in isolation. We have to deal with all the related aspects together, meaning thereby that we have to think about the interlinking of rivers, which government of India is nowadays going at command area development. The entire canal area has to be developed as a unit, groundwater targeting. There may be some desertic areas, the surface water is not available. Can we find some areas where the groundwater can be explored? Rainwater harvesting. Now the government of Haryana has made it mandatory that in the Haryana Urban Development Authority houses, any house which is having the size of more than 200 square yards must have the the artificial the rainwater harvesting system. River basin development, the river we were talking about the National Water Mission. And then now that the land and water resources are to be managed at the watershed level instead of the district level. So all these issues are to be taken together, then only we can think of the water security. And you can understand that when we are talking about the developmental objectives, we must have the integrated water resource management as one of the prime plan for the implementation. Then only we can think of that we must be having the enabling environment where the institutional structures, management instrument and infrastructure development works together so that we can think about the water resource management planning in a very, very second way. I think a lot of theory, then we must move to some of the practical aspects. I will just take you through some of the general observations, then I will take you through some of the case studies. And I hope that we will be able to finish in time so that we are having the time for the inquisitiveness or the questions, answers, which will be there. So when we're talking about, you can see this satellite image. It's a synoptic view ranging from the Himalayas to the Thar Desert. We are having the agricultural land, the agricultural crops are standing, so red color, right? You are having some of these grayish areas or whitish areas. Here also we are having in the northeast, we are having all these snow-covered areas, right? So these are the glaciated regions. Here, these are the Thar Desert, right? This line, which you are able to see, this yellow line, this is the boundary between India and Pakistan. So satellite image, nothing has been done. We have just put the vector layer on it, the boundary, political boundaries. And you can see that we are able to see a particular pattern, which is going like this. If I show you a small area, you may not be able to see that whether it can be a paleo channel, but if you're seeing a synoptic view, we are seeing a regional trend. Yes, it seems to be a river. And when you go to the ground, if I'm going beyond Sirsa district, O2 this is Sirsa district, Haryana, I don't see any imprint on the surface. But if you see this image, you are able to see that this feature is crossing the international boundary, and almost around 50 kilometers beyond, we are able to see that in the desertic area, we are able to see this type of the feature. And this, we in scientific terminology call it as a paleo channel. And my colleagues from Regional Remote Sensing Center, Jodhpur, and the Space Application Center, Ahmedabad, are of the opinion that this is the old course of River Saraswati. Right? But as far as the natural resource management is concerned, in this area, anywhere you go and drill a well, you will get plenty of good quality water, right? So we can use the battery of tube wells to explore the water and then give the water for the life-saving irrigation as well as for the drinking purpose. One, another is across this channel, anywhere you recharge this, the entire course will be recharged, right? Entire course will be recharged. So these type of features are very well visible on the satellite image. Geospatial advantage of geospatial technology, just to emphasize on. Just the same course you see here, right? So this we are able to see. One of my colleague, right, from HARSAC, previously when I was working at Haryana Space Application Center, Hisar, he was working to identify the Kinu plantation. You can see these small red patches, Kinu plantation in Sirsa district. When I was seeing on his monitor, then I was able to see, oh, what a beautiful feature, which I was discussing in the previous slide. I was discussing in this slide, this is Sirsa district. So you see here that this is a old river course, which is in the dimension 2 to 3 kilometers of the width. And we were able to see that this may be the old course of river Saraswati. And I mean, it's very peculiar that it is, flowing from the other side of the city, Sirsa, which as of now, the course is existing. And you can see further that this is not the only course. I would like to draw your attention that this is the Indira Gandhi National Canal, right? IGN. And Indira Gandhi National Canal, this is a diversion. The excess of the water is coming, you are putting this water into here. So you are just putting it in the dunes, right? So you will see that excess of the water, which is, petering out, you are putting that water out here. And that water is taking the shape of a river. Are you able to see this? Right on the screen, right? So this is not, though, I mean, it looks like this was not the only main river course, but it was having a number of tributaries also. So it helps us in identifying that the river which used to flow was a mighty river and it was having a number of tributaries, right? So that indicates when our colleagues, my colleagues from the archaeology and from the, the ancient Indian history department, they say and they talk about the old course of river Saraswati, and they talk about many sites which are present over there, then it coincides that yes, this is the old course of river Saraswati. Then you see this another image. This is from our colleagues. I was talking to you about Regional Remote Sensing Service Center, Jodhpur, and you can see that it is very, very peculiarly, you are able to see that not only the major course, but we were able to see some of these small, you can say, looks like that it was having a number of tributaries. So these are the general observations, but I will draw your attention to the precise information that this is, one of the, I will take you through some of these. This is Mahendragarh district. So this is the Kharif season and this is the Rabi season. These images are there. You can see the change in the crop pattern. And this is 1995. Was the year when Haryana was having worst floods. And you can see that how the floods can be, the flood affected areas can be identified. This is Ghaggar River and this is Yamuna here on this coast. And these are the areas where we are having the either the stagnating water or the water which has receded. So these darkest areas. You can see a little bit the larger that this is Hisar and you can see all the area. The interesting part of it is you will really appreciate that one is that we can identify how much area was affected by the flood. But can you see this? We are having this, the excess of the water has almost taken the shape of a river. Similarly here it is coming up to here. Similarly you can see here. Now it is going like this and then if it's excess water is there, it is coming here. Similarly, this is also coming and joining here and it may also come and join it somewhere. And then you see the other, you can say the channels also, right? So what I want to say is that on the surface now, we don't have any river which is present over there. We don't have any water channel which is present over there. But if you see these type of the satellite images, you see that the excess of the water in the rainy season has taken the low-lying depressional areas, which have been almost because of the anthropogenic influences. These have been almost reduced to almost the rubbles, right? But you can see that, yes, these are the old courses of river Chotang and the Stavati, which used to be the part of which used to flow in this area. So these type of rivers flow. So when I was talking to you about this Mahendragarh district, you can see that I will just draw it down, that just a moment. Okay, so what we did, that we want to manage, we thought that let's manage the land and the water resources of this region. So we have prepared a number of maps. I'm sorry, I will just, if I can really make something. So you can see that this is the slope map of the region. And this you can see that this is the because that my full screen mode is not working, so I will just, this is the soil suitability and capability. So what I did, that we have prepared a number of map of this area, like this is the slope map which we are having here, and this is the you can say the soil suitability. You have prepared the soil map, then you have prepared the soil suitability map. This is the soil map of this particular area. Then you are having the land use land cover map, that what is the present land use in this particular area, what is the surface water channels which are present over there, because why I'm putting it like this, you will not be able to see otherwise. I'm just putting, I mean, these are the different type of the maps which you can prepare with the help of the geospatial technology, right? So you can prepare the map related to geology, geomorphology, land use, land cover, change in the land use, land cover. And our ultimate objective is that when we are getting the information from the ground, these are the ground photographs. This the cropland harvested. You are saying this is the harvested mustard crop. This one, these are the Aravalli Hills. We are having some of the degraded pasture or scrublands. We are having the fallow land and the dunal presence is there. So why we prepared all these maps? We prepared these maps to put into the GIS, the decision support system, a decision rule through which that if there is a patch of land which is single crop, so can we use that if for the silvipasture that we can suggest some local available varieties of trees which are not being only used for that their fruits can be used for human consumption, but the branches are being used as a loping fodder for the animals. So silvipasture, we are having the tree types whose roots are acting as the soil moisture conservation. The fruits are being used for human consumption. The branches are cut in the lean dry season, summer season, for the consumption by the animals. So can there be some silvipasture varieties which can be grown? So we have identified. Agroforestry, we are having the insufficient ground and the surface water is available. So we can go only one, you can say the one crop and then the forestry. So agroforestry, agrohorticulture, along with the agriculture, we are suggesting the farmers to grow some horticultural plants, rain-fed crops. Then there are some of the areas where we have to go for afforestation with soil conservation. So along the Aravalli Hills, we are having the higher slopes. So by trenching, preparing the, some pits, can we go for the afforestation? These type of, the land resource management can be suggested. And then another is integrated groundwater resources, that we are having the maps related to groundwater depth, groundwater quality, and then groundwater availability, right? So these maps, that is the hydrogeomorphology, depth to groundwater and groundwater quality. We have integrated these and we have prepared one map, that is the integrated groundwater resources map. And in this map, we are able to see this area, this one. So this is the area where the groundwater quality prospects, that if we go and drill a well, we will get good quality, very good prospects, and the groundwater quality is good. And if you see that we are having this in the range of 30 to 40 meters. Okay, yeah, okay, little bit, yeah. So 30 to 40 meter water depth is there. So these type of integrated map we have prepared. And then we can also prepare the surface map. Surface water resources action plan map. Surface water resources action plan map. We are having the drainage network where we can suggest some earthen dam, check dam, subsurface barrier, basically to for the soil moisture conservation. Similar type of the work was carried out for Gurgaon district. I'm sorry, actually, if the animation would have been there, so you could have seen one by one map, it would have been really appreciable. I have to find out some way that why this type of problem is there. So this work we did for Mewat area. We submitted the report to the Mewat Development Agency, and then we have used some of these. We have taken the field photographs after the implementation of this project. So they have put some earthen bund here and spillway is there. Then this is a you can say the water pond, right, being used for the groundwater recharge and pisciculture. And then a percolation tank, right? Earthen bund, you can see the vegetation coming up, the water is getting stagnated, water is being recharged in the surrounding areas. And then in the lower reaches, you can see the change in the land use pattern. The tomato cultivation is there in the Bazada. And then we are having these freshwater wells that you are having a tube well in the lower reaches. This is the same where the percolation tank was there in the lower reaches. You can see the vegetation and the public health tube well, right? So, and then you can have the soil erosion to check the soil erosion. You can have these type of the gully plugging, right? You can see by using the locally available material and putting the cementing into that. So this type of gully plugging is there. Then you can again see that you are having the percolation tank on the upper side, and then you are having the tube well by the public health to provide the water to the surrounding areas. I think I will take one. I mean, these type of studies we have carried out in Kathal district. We have carried out in Hisar district also, where we have taken the long. You can say range data from 1990 till 2014, both for the quality and the depth, to see the depth variation and the quality variation, and then suggest the fluctuation, and also these type of groundwater resource maps for the area. Similar type of the study we have carried out. I mean, I'm sorry, again, these are a number of maps. This is a water set, because nowadays the water set is being considered as a unit instead of the political boundaries. So this is the proposed water harvesting structure we have suggested. This is the groundwater potential map of the area. This is the soil erosion risk map. This is the soil, you can say, this is the soil map, sorry. This is the change detection. We have taken the land use of 2015-16, and then we have taken that of 1999-2000, right? So just to compare that, how the land use is changing in this particular area. So we have prepared this aspect map, slope map, distal elevation model, drainage map, geomorphology map, geology map, and this is the map of that particular, I mean, the satellite image of this particular area, how it looks like, right? So basic idea behind it, that after preparing these type of maps, ultimately we can draw certain decision routes through which we can go for the better management of the land and water resources. And nowadays, my dear friends, that lot of discussion is going on, and the ISRO is pioneering some of the projects where the sensor-based monitoring of the soil moisture, cropping system, and so many things. So smart water management, sensor-based technologies are coming up. So I will just take another 2-3 minutes. That you see here that this is Kurukshetra, where I am from, Kurukshetra University. This is famous pond, Brahm Sarovar. This is Kurukshetra University, Kurukshetra, right? And you can see very good agricultural crops are around, but from the groundwater point of view, you can see that every village is having at least 1 or 2 ponds, right? And these ponds are the best way to recharge the groundwater. And now Government of India is emphasizing that can we go for the rejuvenation of old water bodies. And the Government of Haryana has recently passed a bill to restore about 85,000 the old water ponds, so that the water recharge may really take place. I mean, Haryana is, I can say, Haryana is one of the states where we are, I mean, the government is really aware about that the groundwater is to be really preserved. Otherwise, we can really see in the coming time that it may be a desertic state. And I'm consciously using this word. So to conclude, the water on the basis of what said, you can say studies needs to be propagated. Geospatial technology is to be made much more common, and more people are to be made aware about the potential of the geospatial technology, and to really understand the applications of it. And we need to have the pan-India initiatives, and we have to think about the local specific site plans. And we have to have the cooperation from the global, national, and the regional communities. And as of is being done today by the D. Krishnamurthy, and Dr. Pamar and Dr. Rathi, I mean, these type of training and capacity building programs have to become more common. So I think with this, you can see, and Dr. Manoj Pamar has already talked that we have come out with these 3 books recently. This is the latest one, Geostatistics and Geospatial Technology from Groundwater Resources in India. You can just browse through, and the 4th book is coming. That will be more on biodiversity and the land resource management. And with this, I would like to conclude. My friends can see on the screen that these are very, very, very 2 quotes which are very dear to my heart. Very near to my heart. One is by Mahatma Gandhi: "Earth has enough for man's need, but not enough for man's greed." And I see that here, what we are talking about, the geospatial technology, we see the real applications of this technology for the better management of the land and water resources. And you can see that when we are talking about the Abraham Lincoln, that he has rightly said that you cannot escape the responsibility of tomorrow by avoiding it today. So this talks about the sustainability. So with these 2 quotes, I would like to stop and thank you very much. Thank you all for patient listening. And now we can have the question answers, or any curiosity, any questions, any inquisitiveness which my colleagues may have. And if it was a little bit long, or because of, I think, Manoj, I'm sorry that because of these slides, not coming into the full mode, there may be really a little bit inconvenience to my colleagues, but I could not help out. Thank you very much. Now the session we may open for the discussion.
Thank you very much, sir. It was because of the technical glitch that the participants couldn't see all the things that I have seen in previous 2 lectures of yours, and it was very informative session. I open the session for the question and answer, and any queries that have been generated, or any question that you would like to ask from sir to the participants. Anyone from participants?
They have taken a high dose of today's lecture, so maybe they are just in the process of digestion. Manoj?
It was in the feedback session also, like when I was given the subtle program. So at that point of time, they were saying the session is for 2 hours. So 2 hours becomes very heavy dose. So I was discussing with the member secretary, Rajiv Kansalji is from our institute only.
Right.
So we requested him that this session should be 1 hour only.
Okay.
Because in case of more,
at times, I think we can have, or you can have 2 things, like after 45 minutes, there can be a discussion of about 10-15 minutes, and
yes,
then again 45
then
minutes.
Again,
and yeah.
But sir, at that point of time, the break again coming to the same, let's say, level of or pitch of the thing, so it becomes difficult for the speaker also.
Yeah, that I understand.
So that break basically breaks down the stamina, the things.
But I think I'm sure that our colleagues across the disciplines, what I was thinking, that there may be some of the colleagues who are from the different disciplines. So that's why I thought that if they are having a proper glimpse that where we stand and how the things can be done with the help of geospatial technology, I think that will be one of the because they are having 4 more days to come, and they will be having many interesting talks from different colleagues. And I think they will be in a better position to really appreciate the power of geospatial technology.
Sir, most of the participants in the chat box are thanking you for the informative session. On behalf of the participants, thank you very much, sir, again for enlightening all the participants, which include faculty and research scholars of different disciplines and domains across India, and making them aware about the real life problem that we are facing in Haryana. starting from the session of like basic concepts of remote sensing and then the salient features of remote sensing data, then recent mission on Indian remote sensing satellites and various missions taken by Indian government, and then putting a special slide on applications of data captured by using these satellites. You have set a tone on the sessions for the coming days. We feel blessed from your talks each and every time that we get a chance to hear your expertise. You always add new features and knowledge. For example, this time you added water sustainability issue, which was very specific from global, discussing from the global level to Indian level, and then coming to the state of interest, that is Haryana, which we are organizing this FDP. Although the participants are from different states across India, but they will get a, let's say, glimpse of the problems that we are facing in Haryana. A brief about Haryana leading to the dynamics of water resources, linking the same to the sustainable development goals, how we can ensure water accessibility, and the initiatives taken by government of Haryana. Then again, coming back to the same type of problem formulation and then leading to these solutions, and converting the data from thematic maps leading to the knowledge delivery, which are in the form of land resource action plans, groundwater maps, agroforestry, such kind of solutions that you provided. I hope all the participants are benefited from your talk. Sir, the learning is not only from the about the content and the knowledge that you deliver. It is from the younger teaching fraternity that we learn on the flow of the presentation, how you deliver and compose the presentation for delivering the content. Each and every component of your talk remains a learning for the budding professionals in the teaching fraternity. With these lines, sir, we again thank you very much for accepting our request and delivering such an informative talk on the topic of the FDP. Thank you very much, sir. We look forward to hear you again in the February in advanced FDP mode. Thank you very much, sir.
Thank you, Dr. Manoj. There is a question I'm able to see in the chat from Satish Kumar. Satish Kumar is writing this, what are the reliable sources of data for conducting water stress studies in a region or area? Satish, there can be two ways. When we try to understand the stress, one which is very common by using the geospatial technology is that if we are having the the satellite data and we are having the NDVI, we can calculate the NDVI. NDVI is one of the very important indicator of the stress in the crop. One. Second is when we are talking about the data, we are having the Central Water Commission, we are having the CGWB, we are having the state groundwater board. In our place, we are having the groundwater cell, government of Haryana, under the Ministry of Agriculture and Farmer Welfare, right? So these are three different. At the central level, we can get the data as far as the hydrology, surface hydrology is concerned from the CWC, then CGWB, then coming to the groundwater boards of the state. And then depends on your objective, that what type of work you want to do. There may be a need that you have to go to the field and then you have to get the data about the aquifer characterization. We are having certain, you can say, the electrical resistivity survey instruments like the aquameter and the Siskel kit. With the help of that, we can understand, we can find out the thickness of the aquifer, and then we can understand that depending on the rainfall runoff models, we can quantify it in terms of how much you can say the water will be available for the recharge, or how much water is going as a evapotranspiration, consumptive and conjective losses, all those things. So these three are the more important, the most important sources from where you can get the data to supplement your studies. So that's all, Dr. Manoj.
Santoshji, you can unmute yourself.
It was from Satish Kumar. He is saying,
Satish Kumar, yeah, he is thanking you, sir. Santoshji has raised his hand.
Yeah, please, if someone wants.
Kindly unmute yourself.
Santoshji, you can also, okay. Santosh, if you're having some questions, now you can unmute yourself. I think we do have the technical coordinator has made us, we can unmute ourselves and we can.
Sir, please unmute yourself. Manoj sir, please unmute yourself.
Santoshi, kindly unmute yourself.
I think Manoj sir, that may be by by mistake you might have raised.
It seems so, sir.
So no issues. Yeah. Thank you.
Sir, thank you very much, sir. Thank you very much again. We would like to see you in February again, sir.
Thank you very much.
Thank you very
It's a
much, sir.
pleasure.
Thank you, sir. To all the participants,
Sir, any feedback form, sir?
yeah, feedback. I was waiting for that Professor B.H. Chaudhary will leave the meeting, then I'll make the announcements. Sir is
Thank
still in
you,
the
sir.
meeting. Yeah, sir
Thank you.
has- Sir has left.
Thank you.
Yeah, thank you very much everyone for your patience and regularly remaining in the session. You are requested to kindly participate in the discussions also. It'll be very helpful for the speakers also, and it remains very encouraging for the speakers. I'll share you the feedback form on WhatsApp group. And the next thing is all of you are requested to kindly remain in time so that we can start the session very well in time. So thank you very much. Thank you very much for the day. I would like to thank everyone to the end of first day and making it a success. Thank you. Thank you, everyone. I'll share you the feedback form on WhatsApp group.
Thank you, sir.
Okay. Thank you. FDP team, kindly record this meeting and save it.
Okay, sir.
Thank you. Thank you very much.